Picture this. You're standing at your front door after a long day, keys in hand, looking across just 50 feet of familiar ground toward home. It should take you 10 seconds to cross that distance, but what if I told you that according to logic itself, you might never reach that door at all? Not because of any physical barrier, but because of something far more mysterious, a puzzle hidden in the very fabric of space and movement itself. Before you can walk those 50 feet, you must first walk 25 feet. But before those 25, you must walk 12.5, then 6.25, then 3.125. Each step reveals another step that must come first. An infinite series of smaller journeys, each demanding completion before you can proceed. How can anyone complete an infinite number of tasks? Welcome to a realm where common sense meets impossible logic, where the most basic assumptions about reality reveal hidden contradictions that have puzzled the greatest minds for over 2,000 years. Tonight, we'll journey through the landscape of logical paradoxes, those beautiful, bewildering puzzles that show us just how strange our world really is. We'll meet Achilles, the swiftest runner who ever lived. As he discovers he can never catch a simple tortoise, we'll encounter arrows that fly yet somehow never move, and ships that remain themselves while becoming entirely different. We'll visit ancient courtrooms where sentences trap themselves in webs of logic, and watch as crocodiles make promises that create impossible dilemmas. These aren't just abstract puzzles gathering dust in philosophy textbooks. They're windows into the deepest mysteries of existence, questions about time, identity, truth, and the nature of reality itself. They reveal that even the most ordinary moments of our lives rest upon foundations far stranger and more wonderful than we typically imagine. So settle in, get comfortable, and let your mind drift as we explore these timeless riddles. Whether you are seeking the gentle pathway to sleep or simply curious about the beautiful impossibilities that surround us, these ancient puzzles will guide you into a contemplative space where logic and mystery dance together in the twilight of consciousness. Some questions don't have answers. They have something better. They have the power to transform how we see the world, one impossible step at a time. Zeno's dichotomy paradox. Imagine, if you will, that you are standing at your front door, keys in hand, after a long day. Your home lies just 50 feet away across your yard. 50 simple feet. You can see your destination clearly. The warm glow of windows, the familiar outline of your doorway. It should take you perhaps 10 seconds to cross this small distance. And yet, according to a puzzle that has haunted human thought for over 2,000 years, you may never reach that door at all. This is not a story about obstacles or barriers. This is about something far more mysterious, a riddle hidden in the very nature of space and movement itself. It whispers to us that every journey, no matter how brief, might actually be impossible to complete. Not because of any physical impediment, but because of something deeper, something woven into the fabric of reality itself. The ancient Greeks called this puzzle the dichotomy paradox, and it emerged from the brilliant and troubling mind of Zeno of Elea, a philosopher who lived in the 5th century before our era. Zeno was not content to accept the world as it appeared. He looked at the most basic assumptions about motion and distance and found within them seeds of contradiction so profound that they still perplex us today. Let us walk with Zeno back to that moment at your front door. You wish to reach your home 50 feet away, but to travel those 50 feet, you must first travel half that distance, 25 feet. This seems reasonable enough. Before you can complete your journey, you must complete the first half of it. But now, standing at this 25-foot mark, you still have 25 feet remaining. And to travel these remaining 25 feet, you must first travel half of them, 12.5 feet, Do you see where this leads us? At 12.5 feet from your door, you still have that distance to cover, but first you must traverse half of it, 6.25 feet, then half of that, then half again. Each step forward reveals another step that must be taken first. Each portion of your journey splits endlessly into smaller portions, each demanding completion before you can proceed. The numbers become smaller and smaller, 6.25 feet, then 3 1/8, then 1 9/16, then less than an inch, then less than the width of a hair, then distances so tiny that they exist only in the realm of mathematical abstraction. Yet each microscopic segment must still be crossed. Each infinitesimal gap must still be bridged. This is the heart of Zeno's puzzle. Before you can complete any journey, you must complete an infinite number of smaller journeys. And how can anyone complete an infinite number of tasks? How can finite beings like ourselves accomplish something that has no end? Picture this paradox playing out in the simplest moments of daily life. Consider a child reaching for a toy across the room. By Zeno's reasoning, the child must first reach the halfway point, then half of the remaining distance, then half of that, and so on forever. The toy should remain forever out of reach, separated by an endless series of diminishing but never disappearing gaps. Or imagine a raindrop falling from a cloud toward the earth below. Before it can complete its descent, it must fall halfway. Before that halfway point, it must fall half of that distance. The drop should remain suspended forever in the sky, forever progressing through smaller and smaller fractions of its journey, but never arriving at the ground beneath. Yet children do reach their toys, raindrops do fall to earth, you do walk through your front door each evening. The world moves around us with apparent ease, while mathematics seems to suggest that all motion should be impossible. This is what makes Zeno's paradox so haunting. It uses flawless logic to prove something that our senses tell us cannot be true. Zeno crafted this puzzle not to torture us, but to defend the teachings of his mentor, a philosopher named Parmenides. Parmenides had argued that change and motion were illusions, that reality was actually eternal, unchanging, and indivisible. Most people found this idea absurd. How could motion be an illusion when they could see birds flying, watch rivers flowing, feel their own bodies moving through space? Zeno's genius was to show that our common sense about motion led to impossible conclusions. If motion were real, he argued, then these paradoxes would have to be resolved. Since they seemed unresolvable, perhaps motion itself was the illusion Parmenides claimed it to be. Perhaps the world of change and movement that we experience is nothing more than a convincing dream, while true reality remains perfectly still and whole. The paradox reveals something profound about the nature of infinity itself. We live in a world that appears to be made of continuous surfaces and smooth motions, but when we examine these phenomena closely, we discover that they might be composed of infinitely many pieces. The line between your door and where you stand contains infinitely many points. The time it takes you to walk that distance contains infinitely many moments. Everywhere we look, the finite seems to be built from the infinite. This creates a peculiar tension in our understanding. Our minds can conceive of infinite series. We can imagine adding 1/2 plus 1/4 plus 1/8 plus 1/16, continuing forever. Yet we also know that this infinite sum somehow equals exactly 1. Mathematically, we can prove that 1/2 plus 1/4 plus 1/8 plus 1/16, and so on forever, adds up to precisely one whole. The infinite series converges to a finite result. But does this mathematical truth resolve Zeno's puzzle, or does it deepen the mystery? Even if the infinite series of distances adds up to 50 feet, and the infinite series of time intervals adds up to 10 seconds, how do we actually traverse infinitely many distinct segments in finite time? How does the mathematical convergence translate into physical reality? Consider the difference between potential and actual infinity. When we say that the distance between you and your door can be divided infinitely many times, do we mean that those divisions actually exist in reality, waiting to be discovered? Or do we mean simply that we could, in principle, continue dividing forever if we chose to? The first interpretation suggests that space itself is composed of infinitely many real parts. The second suggests that the infinite divisions exist only in our minds as a tool for understanding continuous space. This distinction touches on some of the deepest questions in mathematics and philosophy. Are numbers discovered or invented? Does mathematical truth exist independently of human minds? Or do we create it through our thinking? When we prove that an infinite series converges to a finite sum, are we describing something that exists in nature, or are we simply manipulating symbols according to rules we have established? The paradox also invites us to consider the relationship between time and space. In Zeno's puzzle, the infinite divisions of distance are matched by infinite divisions of time. Each smaller segment of the journey corresponds to a smaller interval of duration. But what is time, really? Is it something that flows, carrying us along from moment to moment? Or is it more like space, a dimension in which past, present, and future all exist simultaneously, and our sense of temporal flow is another kind of illusion? Some modern physicists suggest that space and time are not fundamental features of reality, but emergent properties that arise from something more basic. Perhaps the paradox points us toward this deeper level, where our ordinary concepts of distance and duration no longer apply. Maybe the puzzle persists because we are trying to understand reality using concepts that are themselves approximations of something more fundamental. Yet even if we suppose that space and time are emergent rather than fundamental, Zeno's puzzle retains its power. Whatever the ultimate nature of reality might be, we still experience ourselves as beings who move through space and time. We still face the question of how continuous motion arises from discrete components, or how finite processes can encompass infinite complexity. The paradox also reflects something essential about the human condition. We are beings caught between the finite and the infinite. Our lives are bounded by time and space, yet our minds can conceive of endless series, eternal truths, and unlimited possibilities. We experience ourselves as unified wholes, yet we know that we are composed of countless parts, cells, molecules, atoms, particles, each existing at a different scale of reality. In our daily lives, we constantly navigate this tension between unity and multiplicity, between the continuous and the discrete. When you decide to walk across your yard, you do not consciously coordinate billions of neural signals, thousands of muscle contractions, or hundreds of individual steps. Yet somehow, all of these complex processes organize themselves into the simple, unified experience of walking home. Perhaps this is what Zeno's paradox ultimately teaches us. Not that motion is impossible, but that the relationship between our experience and reality is far more mysterious than we typically assume. The puzzle reminds us that even the most basic aspects of our existence, like the ability to move from one place to another, rest upon foundations that we do not fully understand. When you next find yourself walking toward a destination, whether it is 50 feet away or 50 miles, you might remember Zeno's ancient puzzle. You might pause to wonder at the mysterious process that allows you to traverse infinitely many mathematical points in finite time. You might marvel at the fact that your continuous journey somehow bridges the gap between the infinite and the finite, between what logic suggests should be impossible and what experience shows us is perfectly natural. The paradox does not demand that we choose between mathematics and experience, between logic and common sense. Instead, it invites us to hold both perspectives simultaneously, to remain comfortable with mystery, and to remember that our understanding of even the simplest phenomena remains incomplete. In a world that often pressures us to have definitive answers, Zeno's paradox offers the gift of a profound question, one that has no easy resolution, but which opens our minds to the deeper mysteries that surround us. The paradox extends beyond the realm of pure philosophy and mathematics into the very foundations of how we understand consciousness itself. When you decide to walk toward your door, what exactly makes that decision? Your intention to move seems to arise as a unified whole, a single moment of will. Yet that intention must somehow coordinate with countless neural processes, each firing in precise sequence, each depending on the completion of previous steps. Is consciousness itself subject to Zeno's puzzle? Must each moment of awareness be preceded by half a moment, then half of that? Consider how memory works in relation to this endless subdivision. When you recall walking through your door yesterday, do you remember the complete journey, or do you remember a series of discrete moments strung together? Your memory seems continuous, like watching a film, yet we know that memory is constructed from fragments, pieces of experience that your mind weaves into a coherent narrative. Perhaps Zeno's paradox reveals something fundamental about how all experience is constructed, not as smooth, continuous flows, but as infinite collections of discrete moments that somehow give rise to the illusion of seamless continuity. The ancient Greeks who first encountered this paradox lived in a world very different from ours, yet they grappled with questions that feel remarkably modern. They did not have our knowledge of quantum mechanics, which suggests that at the smallest scales, space and time might indeed be discrete rather than continuous. They could not have imagined that motion at the quantum level is probabilistic rather than deterministic, governed by uncertainty principles that would have fascinated Zeno. Yet their intuition that something profound was hidden in the nature of motion has proven remarkably prescient. Modern physics offers new perspectives on the paradox, but it does not entirely resolve the underlying mystery. Quantum mechanics suggests that at the smallest scales, space might be quantized, made up of discrete units rather than being infinitely divisible. If this is true, then Zeno's infinite subdivision would eventually reach a limit, a smallest possible distance beyond which no further division is possible. Yet even this quantum resolution raises new questions. How does smooth, continuous motion at our everyday scale emerge from discrete quantum processes? The mystery simply moves to a different level. Einstein's theory of relativity adds another layer to the puzzle by revealing that space and time are not the fixed, absolute framework that Zeno assumed. Time can stretch and compress, space can curve and bend, and the simultaneity of events depends on the observer's motion. In this relativistic universe, the very notion of covering half the distance first becomes problematic, because different observers might disagree about what constitutes half the distance, or about the order in which events occur. Yet perhaps the most profound insight that emerges from contemplating Zeno's paradox is not about physics or mathematics, but about the nature of thought itself. The paradox demonstrates how reason, when pushed to its limits, can lead us to conclusions that seem to contradict direct experience. This is not a failure of logic. Zeno's reasoning is impeccable. Rather, it reveals the complex relationship between our conceptual frameworks and the reality they attempt to describe. We might ask whether the paradox tells us something about the limitations of language and thought. When we say that you must cover half the distance first, we are using words and concepts that evolved to help us navigate a world of medium-sized objects moving at ordinary speeds. These concepts work beautifully for their intended purpose, but when we apply them to questions about the ultimate nature of space, time, and motion, they may lead us into conceptual territories where they are no longer adequate guides. The paradox also illuminates the relationship between the abstract and the concrete. In the abstract realm of mathematics, we can indeed conceive of infinite series that converge to finite sums. We can manipulate these concepts with precision and elegance. But the physical world in which we actually move is neither purely abstract nor purely concrete. It exists in some mysterious middle realm where mathematical relationships seem to manifest as physical realities, yet where the translation between abstract concept and concrete experience remains fundamentally mysterious. Think about the role of approximation in how we actually navigate the world. When you walk toward your door, you do not calculate infinite series or worry about traversing infinitely many points. Instead, you rely on approximations. Your visual system estimates distances, your motor system adjusts your gait, your balance system keeps you upright. These approximations work beautifully for practical purposes, but they also suggest that our everyday experience of motion might itself be a kind of approximation of something more complex. This raises profound questions about the relationship between truth and utility. Zeno's paradox is logically rigorous and mathematically precise, yet it seems to describe a world where motion is impossible. Our everyday understanding of motion is practical and effective, yet it may rest upon conceptual foundations that cannot withstand philosophical scrutiny. Which perspective captures the deeper truth? Or is this question itself based on a false assumption that there must be one correct way of understanding motion? The paradox also invites us to consider the nature of explanation itself. When we attempt to explain motion, are we trying to reduce it to something more fundamental, or are we simply translating one mystery into another? The mathematical resolution that infinite series can converge to finite sums is elegant and powerful, but does it truly explain how you manage to walk through your door, or does it simply push the mystery into the realm of mathematical convergence? Perhaps the most beautiful aspect of Zeno's paradox is how it maintains its power to inspire wonder even after more than 2 millennia of analysis. Each generation of thinkers has approached it with new tools and perspectives, yet the fundamental mystery persists. Medieval philosophers saw in it questions about divine omnipotence and the nature of creation. Renaissance mathematicians used it to develop new techniques for handling infinite series. Modern physicists find in it echoes of quantum mechanics and relativity theory. Contemporary philosophers use it to explore questions about consciousness, computation, and the nature of explanation itself. This persistence suggests that the paradox touches on something fundamental about the human condition. We are beings who experience ourselves as unified and continuous, yet we exist in a world that seems to be composed of discrete parts and probabilistic processes. We are finite beings capable of conceiving infinity, mortal creatures who can contemplate eternal truths. Perhaps Zeno's paradox endures because it captures this essential tension in a pure, crystallized form. As you stand at your door tonight, keys in hand, you might reflect on the layers of mystery that surround even this simple moment. The light reaching your eyes has traveled at the speed that defines the very structure of space-time. The decision to move forward emerges from neural processes that science is only beginning to understand. The space you will cross contains more geometric points than there are atoms in the observable universe. The time your journey will take can be divided into intervals smaller than the briefest moments measurable by our finest instruments. Yet somehow, in defiance of logical paradox and mathematical complexity, you will simply walk forward. Your door will grow larger as you approach. Your keys will find their familiar lock. You will step inside into warmth and light and the comfort of home. The infinite will somehow resolve into the finite, the continuous will emerge from the discrete, and the mysterious will manifest as the utterly ordinary. In those 50 feet of familiar ground lies more than a puzzle that has challenged the greatest minds in human history. There lies a reminder that reality is far stranger and more wonderful than our ordinary experience suggests, and that even in the most mundane moments of our lives, we are participants in mysteries that connect us to the deepest questions about the nature of existence itself. Zeno's ancient paradox continues to whisper its haunting question across the centuries, not to frustrate us with its persistence, but to remind us that wonder and mystery are always just a few steps away. Or perhaps infinitely many steps, each smaller than the last. Achilles and the tortoise paradox. Picture the greatest runner who ever lived, swift as the wind across the plains, fleet as a deer through the forest, faster than any mortal who has drawn breath upon this earth. The ancient Greeks called him Achilles, a hero whose very name became synonymous with speed itself. His feet barely touched the ground as he ran, and when he wished to reach a destination, distance seemed to collapse before him like morning mist. Now imagine beside this legendary figure the slowest creature you can conceive. A tortoise, ancient and deliberate, carrying his heavy shell across the earth with the patience of ages. Each step is considered, each movement measured not in seconds, but in the careful rhythm of an unhurried life. When the tortoise decides to travel somewhere, time itself seems to slow down to accommodate his leisurely pace. Common sense tells us what would happen if these two were to race. Achilles would leave the tortoise so far behind that the poor creature would appear motionless by comparison. The race would be over almost before it began, with the hero of Troy crossing the finish line while the tortoise had barely begun his journey. This is the story that our eyes would tell us, the tale that our everyday experience would write. But there is another story hidden within this race, a story that emerges when we examine the nature of pursuit itself with the precise logic of mathematics. This alternative tale was first told by Zeno of Elea, the same ancient philosopher who showed us that any journey might be impossible to complete. In Zeno's version, Achilles never catches the tortoise at all, not because he is too slow, but because the very nature of pursuit contains within it a logical trap from which even the swiftest runner cannot escape. Let us watch this impossible race unfold. Achilles, in his legendary generosity and sporting spirit, grants the tortoise a head start. Perhaps the distance is 100 yards, nothing to a runner like Achilles who could cover such ground in mere moments. The tortoise accepts this advantage graciously and begins his slow, steady progress toward the distant finish line. When the race begins, Achilles explodes forward with the speed that made him famous. His first goal is obvious and simple: reach the point where the tortoise started, that 100-yard mark that the slow creature has abandoned. This should take Achilles perhaps 10 seconds, no more, but here is where our logical tale takes its strange turn. In those 10 seconds that Achilles needs to cover the 100 yards to the tortoise's starting position, what has the tortoise been doing? He has not been waiting patiently for Achilles to arrive. He has been moving forward, slowly but steadily, adding distance between himself and his pursuer. Perhaps in those 10 seconds the tortoise has managed to crawl forward 10 additional yards. Not much, certainly, but enough to remain ahead. So when Achilles reaches the 100-yard mark, he finds it empty. The tortoise has moved on, establishing a new lead position 10 yards further ahead. Achilles now has a new goal: reach this new position, this 110-yard mark, where the tortoise had been when Achilles reached the original starting point. But logic demands that we be precise about what happens next. To cover those 10 yards, Achilles needs perhaps 1 more second. He is, after all, phenomenally fast. Yet in that 1 second, the tortoise continues his relentless forward progress. He manages to crawl perhaps 1 additional yard forward. Again, not much by human standards, but enough to maintain his lead. When Achilles reaches the 110-yard mark, he once again finds only empty ground. The tortoise has moved to a new position, now at the 111-yard mark. The pattern is becoming clear, and it is both beautiful and terrifying in its implications. Achilles must now cover that one remaining yard, which takes him perhaps 1/10 of a second. But in that 1/10 of a second, the tortoise moves forward by 1/10 of a yard. Then Achilles must cover that 1/10 of a yard, which he does in 1/100th of a second, during which the tortoise advances by 1/100th of a yard. Then Achilles must cover that 100th of a yard, which takes 1/1000th of a second, during which the tortoise moves forward by 1/1000th of a yard. The pattern extends infinitely. Each time Achilles reaches the point where the tortoise was, he finds that the tortoise has moved to a new position. The distances become smaller and smaller. Yards become feet, feet become inches, inches become fractions too small to measure. The time intervals shrink correspondingly. Seconds become milliseconds, become microseconds, become durations shorter than the briefest moments physics can detect. Yet no matter how small these distances and time intervals become, they never reach zero. There is always some gap, however tiny, between Achilles and his quarry. There is always another position that Achilles must reach, always another interval of time during which the tortoise can extend his lead, even if by an amount too small for our instruments to measure. This is the heart of Zeno's second great paradox. Logic seems to prove that Achilles, the swiftest of mortals, can never overtake the tortoise, the slowest of creatures. Not because the tortoise is faster, but because the very act of pursuit requires Achilles to complete an infinite sequence of tasks, reaching the tortoise's first position, then his second position, then his third, and so on forever. The paradox reveals something profound about the relationship between mathematics and reality. We can calculate precisely where and when Achilles should overtake the tortoise. The mathematics is straightforward. If Achilles runs 10 times faster than the tortoise crawls, and if the tortoise has a 100-yard head start, then Achilles will catch up at the 111 1/9 yard mark after 11 1/9 seconds of running. Yet Zeno's analysis suggests that to reach this calculated meeting point, Achilles must first complete an infinite number of smaller tasks. How can any runner, no matter how swift, complete infinitely many tasks in finite time? How can the finite emergence from the infinite? How can the continuous arise from the discrete? The paradox becomes even more mysterious when we consider what it means for the tortoise. From the tortoise's perspective, he is simply walking forward at his natural pace, unaware that he has become the protagonist of an impossible story. He does not feel the infinite series unfolding behind him. He does not sense the mathematical trap that has ensnared his famous pursuer. To the tortoise, this is simply another day's journey, notable only because an unusually fast companion happens to be traveling in the same direction. This raises profound questions about the nature of experience itself. If Zeno's logic is correct, then the tortoise is participating in an infinite process without being aware of it. Every moment of his forward progress corresponds to another term in the endless series that governs Achilles' pursuit. The tortoise's simple walk becomes part of a mathematical drama of cosmic proportions. Consider what this means for our understanding of competition and achievement. We tell stories about races to celebrate speed, determination, and the triumph of skill over obstacles. Yet Zeno's paradox suggests that every pursuit, every chase, every effort to catch up with someone ahead of us involves navigating an infinite logical labyrinth. The runner who passes another runner on a track, the student who catches up with classmates who had a head start, the worker who closes the gap with more experienced colleagues. All are, according to this paradox, accomplishing something that logic suggests should be impossible. The paradox also illuminates the strange relationship between potential and actual infinity. When we say that Achilles must complete infinitely many tasks to catch the tortoise, do we mean that these tasks actually exist as separate, discrete challenges? Or do we mean simply that we can conceptually divide his pursuit into infinitely many stages if we choose to analyze it that way, this distinction touches on fundamental questions about the nature of time and space. Is time really composed of separate moments, like frames in a film, or is it a continuous flow that we artificially divide for the purpose of analysis? Is space really made up of distinct points, or is it a seamless continuum that exists prior to any mathematical description we might impose upon it? Some philosophers have suggested that Zeno's paradoxes reveal the limitations of applying mathematical analysis to physical reality. Mathematics deals with perfect abstractions, infinitely precise points, perfectly straight lines, exact numerical relationships. But the physical world might be fundamentally different from these mathematical idealizations. Perhaps space and time are not infinitely divisible in reality, even if they are in our mathematical models. Others argue that the paradox reveals something deeper about the relationship between logic and experience. Our logical analysis leads us to conclude that Achilles can never catch the tortoise, yet our experience tells us that faster runners do overtake slower ones. Rather than discarding either logic or experience, perhaps we need to develop more sophisticated ways of understanding how they relate to each other. The paradox also invites reflection on the nature of limits and convergence. Modern mathematics shows us that infinite series can converge to finite sums. The infinite series of distances that Achilles must cover adds up to exactly the distance he needs to travel to catch the tortoise. The infinite series of time intervals he requires adds up to exactly the time needed for the overtaking to occur. But does this mathematical resolution truly solve the paradox, or does it simply translate the mystery into different terms? Even if we can prove that the infinite series converges, we still face the question of how Achilles actually manages to complete infinitely many distinct tasks in finite time. The mathematical proof tells us that it should be possible, but it does not explain how the impossibility is overcome in practice. Perhaps the deepest insight offered by this paradox concerns the nature of continuity itself. Our everyday experience of motion feels smooth and seamless. When Achilles runs, he does not seem to be completing a series of discrete tasks. His motion flows naturally from one moment to the next, from one position to the next, without apparent interruption or hesitation. Yet when we analyze this smooth motion logically, we find within it an infinite complexity. Every continuous process, when examined closely enough, reveals itself to be composed of infinitely many parts. Every smooth curve contains infinitely many points. Every flowing movement encompasses infinitely many positions and moments. This suggests that continuity and infinity are intimately connected in ways that our everyday thinking rarely acknowledges. We live in a world where the continuous and the infinite interpenetrate at every level. The simple act of Achilles catching the tortoise becomes a window into the fundamental structure of reality itself. The paradox endures because it captures something essential about the human condition. We are beings who experience ourselves as continuous and unified, yet we exist in a world that reveals infinite complexity whenever we examine it closely. We are finite creatures capable of conceiving infinities, temporal beings who can contemplate eternal truths. When we watch a race today, whether between human athletes or between children playing in a park, we might remember Zeno's ancient puzzle. We might marvel at the fact that every overtaking, every successful pursuit, somehow bridges the gap between the finite and the infinite. We might wonder at the mysterious process that allows continuous motion to emerge from infinite complexity, that permits the impossible to manifest as the utterly ordinary. The race between Achilles and the tortoise continues in our minds more than 2 millennia after Zeno first described it. It is a race that logic says can never end, yet a race that experience tells us must eventually be won. In that contradiction lies not frustration, but invitation. An invitation to remain curious about the deepest mysteries of motion, time, and the nature of reality itself. The tortoise continues his patient journey, Achilles continues his eternal pursuit, and we continue to wonder at the beautiful impossibility of it all, the arrow paradox. Imagine standing in an ancient field at the moment of dawn, watching as an archer draws back the string of her bow. The arrow rests against the wood, perfectly still, waiting. In the growing light, every detail is sharp and clear. The fletching aligned with precision, the bronze point gleaming, the shaft straight and true. This arrow exists in a state of perfect rest, occupying exactly one position in space, claiming precisely the amount of room that its physical form demands. Now watch as the archer releases her grip. The arrow springs forward, cutting through the morning air with graceful purpose. It soars across the field in a smooth arc, covering distance with what appears to be effortless motion. Our eyes follow its path from bow to target, and everything about this sight confirms what we know about the world. Objects can move through space, traveling from one location to another in flowing, continuous motion. But hidden within this simple scene lies one of the most profound puzzles ever contemplated by the human mind. It is a riddle that strikes at the very heart of what we mean when we say that something is in motion. This puzzle emerged from the brilliant and troublesome mind of Zeno of Elea, the same ancient philosopher who showed us that journeys might be impossible to complete and that swift Achilles might never catch a slow tortoise. But if the arrow is motionless at this instant and motionless at the next instant and motionless at every individual instant throughout its flight, then when exactly is it moving? When does the motion that we observe actually take place? How can something that is stationary at every moment of its existence be said to be in motion at all? This is the crystalline logic of Zeno's paradox, sharp and clear as the point of the arrow itself. It uses our most basic assumptions about time and space to prove that motion. The phenomenon we observe constantly around us is actually impossible. Every moving object, from the grandest planet in its orbit to the smallest dust mote dancing in a sunbeam, must at every instant of its existence be perfectly still. The paradox reveals a profound mystery hiding in our concept of an instant. We speak casually of moments and instants as if we understand what they are. But what exactly is an instant of time? Is it something that has duration, however brief? If so, then within that duration, the arrow could indeed move from one position to another, and the paradox dissolves. But if an instant has duration, then it can be divided into smaller instants, and we can ask the same question about each of these smaller parts. Or is an instant truly durationless, a mathematical point in time that separates the past from the future? If so, then nothing can happen in an instant. No movement, no change, no process of any kind. In a durationless instant, the arrow simply exists at a location, frozen like a sculpture, defined by its position alone. This leads us deeper into the mystery of time itself. We experience time as flowing, carrying us from past through present into future. We feel ourselves moving through time, or perhaps time moving through us. Yet when we try to pin down exactly what the present moment is, it seems to vanish like mist. The present appears to be nothing more than the knife-edge boundary between the past that no longer exists and the future that does not yet exist. Consider how this paradox transforms our understanding of the archer's art. The skilled archer must calculate trajectory, account for wind and distance, anticipate the target's movement. All of this expertise seems to assume that arrows do indeed fly through the air. That motion is not only possible but predictable. Yet if Zeno's logic is sound, then archery becomes the most impossible of arts. The skill of launching objects that cannot move toward targets they cannot reach. The paradox becomes even more mysterious when we consider what it means for our perception of motion. When we watch the arrow fly, our eyes track its path smoothly across the sky. Our visual system creates for us the experience of continuous movement. But perhaps what we are really seeing is a series of still images like frames in a film, each showing the arrow at a slightly different position. The motion we perceive might be nothing more than an illusion created by our minds as they stitch together these discrete, motionless snapshots. This connects to profound questions about the nature of change itself. Motion is just one kind of change, the change of position over time. But Zeno's logic applies to any kind of change. If we consider the arrow not just as it moves through space, but as it experiences any kind of transformation, we face the same paradox. At any instant, the arrow has specific properties, a particular temperature, a certain velocity, an exact orientation. At that instant, it is not changing from one state to another because the instant provides no duration within which change could occur. Yet we observe change constantly. The arrow warms as it flies through the sun, cools as it passes through shade. It slows due to air resistance, its orientation shifts slightly due to wind. How can these changes occur if the arrow is frozen at every instant of its existence? The paradox also illuminates the relationship between mathematics and physics. In mathematics, we can define velocity as the derivative of position with respect to time, the instantaneous rate of change of position. This mathematical concept works beautifully for solving problems and making predictions. But what does it mean physically to say that something has an instantaneous velocity? How can there be a rate of change at an instant when, according to Zeno's logic, nothing changes at any instant? Some modern philosophers and physicists have suggested that the paradox reveals the limitations of thinking about time as composed of discrete instants. Perhaps time is not made up of individual moments strung together like beads on a string. Perhaps time is fundamentally continuous, and our habit of dividing it into instants is a useful fiction rather than a description of reality. Others argue that the paradox points toward the quantum nature of reality. In quantum mechanics, particles do not have precise positions and velocities at the same time. The very act of measuring a particle's exact position makes its velocity uncertain, and vice versa. Perhaps Zeno's paradox anticipated this fundamental uncertainty, suggesting that our classical concepts of definite position and definite motion cannot both be applied simultaneously to real objects. The paradox also raises questions about the nature of existence itself. What does it mean for the arrow to exist? Is existence something that occurs at instants, or is it something that extends through time? If the arrow exists only at instants, and if it is motionless at each instant, then its motion must be something that exists between instants. But what could exist between durationless points in time? This perspective transforms our understanding of identity over time. Is the arrow that leaves the bow the same arrow that strikes the target? If the arrow is motionless at every instant, then perhaps it is more accurate to say that there are infinitely many different arrows, each existing at a different instant, each in a slightly different position. The motion we observe might be nothing more than the succession of these different arrows, like the succession of still images that creates the illusion of motion in a film. These questions connect to ancient philosophical puzzles about personal identity. Are you the same person you were yesterday or last year or in childhood? If you change continuously over time, in what sense do you remain the same person? Zeno's arrow faces the same puzzle. If it is motionless at every instant, in what sense can we speak of it as a single, moving object? The paradox also invites us to consider the role of observation in defining motion. Motion seems to be something we observe from the outside, a relationship between an object and its surroundings as viewed by a spectator. But what would motion be like from the arrow's perspective? If consciousness could somehow be associated with the arrow, would it experience itself as moving, or would it experience itself as stationary at each moment, with the world changing around it? This subjective dimension of the paradox connects to our own experience of being conscious beings existing in time. We experience ourselves as persistent selves, maintaining our identity while moving through time and space. Yet if we accept Zeno's logic, then at each instant we are frozen, motionless in both space and time. Our sense of movement through life, our feeling of growing and changing and progressing, becomes as paradoxical as the arrow's flight. Perhaps the deepest insight offered by the arrow paradox is its revelation of the mysterious relationship between continuity and discreteness, between the smooth flow of experience and the sharp precision of logical analysis. Our experience tells us that motion is real, natural, and ubiquitous. Our logic tells us that motion is impossible, contradictory, and illusory. Both perspectives seem valid within their own domains, yet they seem fundamentally incompatible. This incompatibility might not be a flaw in our thinking, but rather a window into the true complexity of reality. Perhaps the world is neither purely continuous nor purely discrete, neither entirely logical nor entirely experiential. Perhaps reality exists in the tension between these perspectives, in the creative space where paradox gives birth to deeper understanding. When you next watch an arrow in flight or any object in motion, you might remember Zeno's ancient puzzle. You might pause to wonder at the mystery contained in something as simple as a bird flying overhead or a leaf falling from a tree. You might marvel at the fact that motion, which seems so natural and effortless, conceals within it logical depths that have puzzled the greatest minds for over 2,000 years. The arrow continues its eternal flight through the landscape of human thought, frozen at every instant yet somehow traversing infinite distance, motionless at each moment yet somehow reaching its target. In its paradoxical journey lies not frustration, but invitation. An invitation to remain open to mystery, to hold seemingly contradictory truths in creative tension, and to remember that even the most familiar phenomena in our world contain depths that we are only beginning to fathom. Consider how this paradox extends into the realm of human action and decision-making. When you choose to move your hand to reach for something, what exactly is happening at each instant of that movement? At any given moment, your hand occupies a specific position in space. According to Zeno's logic, at that instant it is not moving toward your target but simply existing where it is. Yet somehow, through an accumulation of such motionless instants, purposeful action emerges. This raises profound questions about free will and agency. If we are frozen at every instant of our existence, when do we actually exercise choice? When does intention translate into action? The gap between deciding to move and observing movement seems to contain the same infinite puzzle that governs the arrow's flight. Perhaps consciousness itself is subject to Zeno's paradox, existing in a series of discrete, motionless moments of awareness that somehow give rise to the flowing narrative of experience. The paradox also transforms our understanding of causation. We typically think of causes leading to effects through time. The archer's release causes the arrow's flight, the arrow's impact causes the target to be struck. But if nothing actually moves from one moment to the next, how can causes propagate through time? Perhaps causation, like motion, is an emergent property that arises from the relationships between motionless instants rather than something that occurs within time. This perspective opens up fascinating questions about the nature of physical laws. Newton's laws of motion describe how objects behave over time, relating forces to accelerations, predicting future positions from present conditions. But these laws seem to assume that objects actually do move from one moment to the next. If Zeno's paradox is correct, then perhaps these laws are not descriptions of how objects move, but rather descriptions of the patterns that emerge from the succession of motionless states. The paradox becomes even more intriguing when we consider its implications for our understanding of energy. Kinetic energy is traditionally defined as the energy of motion, the energy possessed by a moving object by virtue of its motion. But if objects are motionless at every instant, when do they actually possess kinetic energy? Perhaps energy, like motion itself, is not something objects have at instants, but rather something that emerges from the relationships between different instants. In the quantum realm, the paradox takes on new dimensions. Quantum mechanics tells us that particles can exist in superposition states, occupying multiple positions simultaneously until they are observed. From this perspective, perhaps Zeno's paradox dissolves because the arrow does not occupy a definite position at any given instant. Instead, it exists in a cloud of probability spread across multiple potential positions. Motion might emerge not from the succession of definite positions, but from the evolution of probability waves through space and time. Yet even this quantum resolution raises new puzzles. If the arrow exists in superposition, when does it collapse to a definite state? What triggers this collapse, and how does it relate to our observation of the arrow's motion? The measurement problem in quantum mechanics seems to echo Zeno's original paradox in new form. How does the definite emerge from the indefinite, the classical from the quantum, the observed from the unobserved? The paradox also illuminates the strange relationship between mathematics and reality. In calculus, we routinely calculate instantaneous velocities by taking limits of average velocities over decreasing time intervals. This mathematical procedure works beautifully and produces accurate predictions. But what does it mean physically? Are we calculating something that actually exists at instants, or are we using a mathematical fiction to capture relationships that exist between instants? Some philosophers have suggested that mathematics and physics operate in different domains. Mathematics deals with abstract structures and relationships, while physics deals with concrete reality. From this perspective, the paradox arises when we conflate mathematical concepts like instantaneous velocity with physical realities like actual motion. Perhaps the arrow's motion is a physical phenomenon that cannot be reduced to mathematical relationships between instantaneous states. Others argue that the paradox reveals the fundamental mathematical structure of reality itself. If the universe is, at its deepest level, mathematical in nature, then perhaps the paradox points toward aspects of this mathematical structure that our everyday thinking fails to grasp. Maybe motion is indeed impossible in the way we typically conceive it, but possible in ways that require more sophisticated mathematical frameworks to understand. The paradox also connects to ancient questions about the nature of space itself. Is space a container within which objects move, or is it a relationship between objects? If space is absolute and exists independently of the objects within it, then the arrow's position at each instant is well defined relative to this absolute framework. But if space is relational, emerging from the patterns of relationships between objects, then the arrow's position at any instant might not be well defined until we specify its relationship to other objects. Einstein's theory of relativity suggests that space and time are indeed relational rather than absolute. In this relativistic universe, motion becomes relative to the observer. What appears motionless to one observer might appear to be moving to another. This relativistic perspective adds layers of complexity to Zeno's paradox. If motion is relative, then perhaps the question of whether the arrow is moving at any given instant cannot be answered without specifying the reference frame from which it is observed. The paradox also invites reflection on the nature of artistic representation. When a painter captures an arrow in flight on canvas, what exactly has been depicted? The painting shows the arrow at a single instant, frozen in time, occupying a specific position in space. Yet somehow, skilled artists can convey a sense of motion even in static images. They capture not just where the arrow is, but somehow suggest where it has been and where it is going. This artistic achievement seems to contradict Zeno's logic. If the arrow is truly motionless at every instant, then a painting showing it at one instant should capture its complete reality at that moment. Yet we recognize that such a painting, no matter how skillfully executed, captures only a fragment of the arrow's full reality. The motion that the painting suggests but cannot literally contain seems to be something real and important, something that exists beyond what can be captured at any single instant. Performance arts like dance and music face similar puzzles. A dancer's movement cannot be captured in a single moment, yet it is composed of positions that the dancer occupies at each instant. Music unfolds through time, yet at any given moment, only one note or silence exists. How do these temporal arts create meaning and beauty from successions of instantaneous states? These artistic considerations point toward a deeper truth about the paradox. It reveals the tension between analysis and synthesis, between breaking complex phenomena down into simple components and understanding how those components combine to create emergent properties. Zeno's paradox emerges when we analyze motion by breaking it down into instantaneous states. But perhaps motion is fundamentally a synthetic phenomenon that cannot be understood through analysis alone. This connects to broader questions about reductionism and emergence in science and philosophy. Can complex phenomena always be understood by breaking them down into simpler parts? Or are there aspects of reality that exist only at higher levels of organization? Perhaps motion is an emergent property that arises from but cannot be reduced to instantaneous states, just as consciousness might emerge from but cannot be reduced to neural activity, or life might emerge from but cannot be reduced to chemical reactions. The enduring power of Zeno's arrow. Paradox lies not in its ability to prove that motion is impossible, but in its capacity to reveal the deep mysteries hidden within our most basic concepts. It shows us that time, space, motion, and change, phenomena so familiar that we rarely question them, contain logical depths that have challenged human understanding for millennia. When we watch an arrow arc across the sky today, we might remember that we are witnessing something that touches the very foundations of reality. The simple flight of that arrow connects to questions about the nature of time, the structure of space, the meaning of existence, and the relationship between mathematics and the physical world. In its graceful trajectory lies encoded mysteries that connect ancient Greek philosophy to modern quantum mechanics, classical logic to contemporary questions about consciousness and free will. The archer releases her grip, the arrow springs forward, and in that simple act lies encoded one of the most profound questions ever asked about the nature of reality itself. The arrow flies through space that might be continuous or discrete, through time that might flow or exist all at once, propelled by forces that might be fundamental or emergent. At every instant of its flight, it is perfectly motionless, yet somehow it reaches its target. The question echoes across the centuries, as sharp and true as the arrow's point, as mysterious and beautiful as its impossible flight through the still moments of time, reminding us that even in the most familiar phenomena lie depths of mystery that continue to inspire wonder and drive the endless human quest to understand the nature of existence itself. The Stadium Paradox Picture. An ancient stadium, carved from stone and filled with the anticipation of thousands. But this is not a stadium built for athletic contests or dramatic performances. This is a theatre designed by Zeno of Elea to showcase perhaps the most bewildering of his logical puzzles. A demonstration that challenges our most fundamental assumptions about time itself and the very meaning of simultaneity. In this stadium, we find 3 rows of seats, each containing an equal number of spectators. Let us say each row holds 10 people, though the exact number matters less than the precise arrangement. The middle row sits motionless, a fixed reference point in our unfolding drama. The spectators in this central section have agreed to remain perfectly still throughout the demonstration, serving as witnesses to the strange events about to unfold around them. But the rows above and below are different. The upper row has been constructed on a platform that can slide smoothly to the right, carrying its 10 occupants with it. The lower row rests on a similar platform designed to glide effortlessly to the left. When our demonstration begins, these 2 rows will move past the stationary middle row at equal speeds, but in opposite directions. From your vantage point outside the stadium, watching this carefully choreographed display, the setup seems simple enough. 2 rows of people moving past a 3rd row at constant velocities. Basic arithmetic should tell us everything we need to know about the timing of their encounters. Yet hidden within this elementary scenario lies a logical trap so subtle and profound that it has puzzled thinkers for more than 2 millennia. Let us watch as the performance begins. The 2 movable platforms start their journey from positions where they are perfectly aligned with the stationary middle row. Each person in the upper row sits directly across from someone in the middle row, and each person in the lower row does likewise. The arrangement is symmetric and orderly, a picture of geometric perfection. Now the platforms begin to move. The upper row glides steadily to the right, while the lower row slides smoothly to the left. As they move, people from the upper row begin to pass by people from the middle row. Simultaneously, people from the lower row pass by these same people in the middle section. The 3 rows flow past each other in a carefully orchestrated dance of relative motion. Here is where Zeno's logical trap begins to close. Consider what happens from the perspective of someone sitting in the stationary middle row. As they watch, each person from the upper row passes by them at a certain rate. Let us say it takes 1 unit of time for each upper row person to move from being directly in front of them to being completely past them. This seems straightforward enough. A simple measurement of relative velocity. But now, observe the same process from the perspective of someone in the upper row. From their viewpoint, they are stationary while the middle row moves past them to the left. Each person in the middle row passes by them in exactly the same 1 unit of time. This also makes perfect sense. The relative motion appears the same regardless of which perspective we adopt as our reference frame. The puzzle emerges when we consider what happens between the upper and lower rows. Remember that both are moving, but in opposite directions. The upper row moves right, while the lower row moves left. This means they approach each other at twice the speed that either approaches the stationary middle row. Logic dictates that people from the upper row should pass by people from the lower row in half the time. Half a unit of time rather than a full unit. But here, Zeno springs his trap. He asks us to count the number of encounters that occur during our stadium demonstration. In the time it takes for 1 person from the upper row to pass completely by 1 person in the middle row. our standard unit of time. How many people from the upper row pass by people from the lower row? The answer seems to be 2. Since the relative speed is double, twice as many encounters should occur in the same period. 2 people from the upper row should pass by 2 people from the lower row in the time it takes 1 person from the upper row to pass by 1 person in the middle row. Yet this creates an impossible situation. We have established that it takes 1 unit of time for 1 upper row person to pass 1 middle row person. We have also established that in this same unit of time, 2 upper row people pass by 2 lower row people. But this seems to suggest that 1 unit of time and half a unit of time are somehow the same duration. Time itself appears to be elastic, stretching and contracting depending on our frame of reference. This is the essence of Zeno's stadium paradox, sometimes called the moving rows paradox. It appears to prove that time is not the uniform, absolute flow that our common sense suggests. Instead, time seems to depend on the relative motion of the observers measuring it. What counts as simultaneous for one observer might not be simultaneous for another. The very concept of now becomes problematic when viewed from different moving perspectives. The paradox becomes even more mysterious when we consider what it means for the concept of sequence. From the perspective of the middle row, the events in the upper and lower rows occur in a certain order. But from the perspective of the upper row, the same events might appear to occur in a different sequence. Which order is the real one? Which perspective captures the true temporal structure of events? This ancient puzzle anticipates by more than 2 millennia one of the most revolutionary insights of modern physics. Einstein's theory of relativity tells us that simultaneity is indeed relative, that events which appear simultaneous to one observer may not appear simultaneous to another observer moving at a different velocity. The now that seems so immediate and absolute in our personal experience is actually dependent on our state of motion relative to the events we are observing. But Zeno developed his paradox not to anticipate Einstein, but to defend the philosophy of his teacher Parmenides. Parmenides had argued that change and motion were illusions, that true reality was eternal and unchanging. The stadium paradox was designed to show that our common sense notions about motion and time lead to logical contradictions. If motion creates these impossible situations regarding the nature of time, perhaps motion itself is the illusion. The paradox also reveals something profound about the relationship between discrete and continuous time. If we think of time as composed of indivisible units, moments that cannot be subdivided further, then the paradox seems to show that these units must somehow be elastic, able to stretch and contract depending on the motion of the observer. But if time is continuous and infinitely divisible, then the paradox raises questions about what it means to measure duration at all. Consider how this affects our understanding of measurement itself. All measurement seems to require some form of comparison. We measure lengths by comparing them to standard units. We measure masses by comparing them to reference weights. But the stadium paradox suggests that measuring time might be fundamentally different from measuring other quantities. When we measure spatial relationships, we can bring objects together for direct comparison. But temporal events cannot be brought together in the same way. They are separated by the very thing we are trying to measure. The paradox also illuminates the relationship between individual and collective experience. Each person in our stadium has their own perspective on the events unfolding around them. From their individual viewpoint, they observe a certain sequence of encounters, a particular rhythm of meetings and partings. Yet when we try to combine all these individual perspectives into a single, objective account of what happens, we discover that they cannot be reconciled into a consistent whole. This fragmentation of perspective raises profound questions about the nature of truth itself. Is there one correct description of the events in the stadium, or are all the different perspectives equally valid? If people in different rows experience different temporal relationships between the same events, which experience captures the true nature of time. The paradox suggests that perhaps there is no single, privileged perspective from which to view temporal relationships. Modern quantum mechanics adds another layer to these questions. At the quantum level, the very act of observation affects the phenomena being observed. Perhaps the temporal relationships in our stadium depend not just on the relative motion of the observers, but on the specific ways in which they observe and measure the events around them. The act of measurement might itself be part of what determines the temporal structure of experience. The paradox also connects to questions about consciousness and the experience of time. Each person in our stadium is presumably conscious, experiencing the flow of events from their own unique perspective. But consciousness seems to require a sense of temporal continuity, an awareness that connects past experiences to present ones and anticipates future possibilities. How does this subjective experience of temporal flow relate to the objective temporal relationships that the paradox calls into question? Some philosophers have suggested that consciousness itself might be what creates the illusion of objective time. Perhaps there is no universal now shared by all observers, but rather a collection of individual nows that consciousness projects onto the world. From this perspective, the stadium paradox reveals not a problem with our understanding of time, but a glimpse into the fundamental role that consciousness plays in constructing our experience of temporal reality. The paradox also raises questions about causation and the relationship between events. If temporal sequence depends on the observer's frame of reference, how can we determine which events cause which other events? In our stadium, does a person from the upper row cause someone in the lower row to turn their head, or does someone in the lower row cause the person in the upper row to wave? The answer might depend on which frame of reference we choose as fundamental. These questions become particularly acute when we consider communication between the different rows. If someone in the upper row shouts a greeting to someone in the lower row, when does the message travel between them? The sound wave must propagate through the air at a finite speed, but its journey takes place in a context where the very nature of simultaneity is in question. How do we account for the time it takes signals to travel between observers who disagree about temporal relationships? The stadium paradox also invites reflection on the nature of space itself. The geometric relationships in our stadium seem clear and well defined. We can specify the positions of all the spectators and the distances between the rows. But if time is relative to motion, and if space and time are intimately connected, then perhaps spatial relationships are also more complex than they appear. The distance between two rows might depend on the relative motion of the observer measuring that distance. This connects to broader questions about the relationship between mathematics and physical reality. The paradox can be analyzed using precise mathematical tools. We can calculate velocities, measure distances, and track the timing of encounters with numerical precision. Yet the mathematical analysis seems to lead us to conclusions that challenge our basic intuitions about time and simultaneity. Does this mean that mathematics reveals truths about reality that are hidden from common sense, or does it mean that mathematical abstractions sometimes lead us away from physical truth? Perhaps the deepest insight offered by the stadium paradox is its revelation that even our most basic concepts, time, simultaneity, sequence, causation, contain hidden complexities that emerge only under careful logical examination. The paradox shows us that the world is not as simple as our everyday experience suggests. That phenomena, which seem straightforward and unproblematic, actually rest upon foundations that are far from secure. When you next find yourself in a crowded place, perhaps a real stadium or a busy train platform, or simply walking down a crowded street, you might remember Zeno's ancient puzzle. You might observe the complex patterns of relative motion around you, the ways in which people approach and pass each other at different velocities and in different directions. You might wonder about the temporal relationships between all these encounters, about whether the now you experience is the same now experienced by others moving at different speeds. The three rows of spectators continue their eternal dance through the landscape of human thought, passing each other at velocities that seem to stretch and compress time itself. Their movement raises questions that connect ancient Greek philosophy to modern physics, individual experience to collective reality, mathematical precision to physical mystery. In their carefully choreographed encounters lies encoded one of the most profound puzzles about the nature of time, simultaneity, and the relationship between observers and the events they observe. The demonstration in Zeno's Stadium never ends because each viewing reveals new layers of complexity, new questions about the foundations of temporal experience. The rows slide past each other with mechanical precision, yet their motion contains logical depths that continue to challenge our understanding more than 2,000 years after the paradox was first conceived. In their passage lies not frustration, but invitation. An invitation to question our most basic assumptions about time, to remain open to mystery, and to remember that even the simplest phenomena in our world may contain complexities that we are only beginning to fathom. The Sorites paradox. Imagine walking along a beach at low tide, where the retreating waters have left behind countless grains of sand scattered across the shore. The evening light catches these tiny fragments of quartz and shell, each grain no larger than a pinhead, each one insignificant when considered alone. Yet as you walk, you notice that in some places these individual grains have gathered together into small mounds, little hills of sand that children might have built during their play, or that the wind and waves have sculpted through patient, persistent work. One particular mound catches your attention. It rises perhaps 2 feet above the surrounding beach, a respectable heap of sand that clearly deserves the name. It contains thousands upon thousands of individual grains, each contributing its tiny mass to the whole. This is undoubtedly a heap, a pile, a mound, an accumulation that any reasonable person would recognize as such. No one could look upon this collection of sand and deny its essential heapness. But now imagine that you decide to conduct an experiment with this heap. You reach down and carefully remove a single grain of sand from its peak, holding it up to examine in the fading light. This lone grain is almost weightless in your palm, so small that a breath of wind might carry it away. Surely you think removing just this one grain cannot have destroyed the heap. The mound that remains, though technically smaller by 1 grain, is still unmistakably a heap of sand. So you remove another grain, then another, then another. Each time, the removal of a single grain seems insignificant. How could subtracting 1 grain from thousands possibly transform a heap into something that is not a heap? The difference is so minute as to be undetectable. Logic and common sense agree. If you have a heap of sand and you remove just 1 grain, you must still have a heap of sand. This reasoning seems unassailable. 1 grain cannot make the difference between heap and non-heap. The concept itself suggests something gradual, accumulated, substantial. Qualities that cannot depend on the presence or absence of a single tiny particle. A heap is a heap because of its overall character, not because of any particular grain it happens to contain. Yet, if you continue this process, removing 1 grain at a time, each time applying the same reasoning, a strange and troubling conclusion begins to emerge. After removing 1 grain, you still have a heap. After removing 2 grains, you still have a heap. After removing 100 grains, surely you still have a heap. The pile remains substantial, visible, significant. Even after removing 1,000 grains, the remaining mound might still qualify as a heap by any reasonable standard. But the process continues, grain by grain, the pile diminishes. Yet at each step, the logic remains the same. 1 grain cannot make the crucial difference. If you had a heap before removing a grain, you must have a heap after removing it. The reasoning that seemed so sound for the first grain applies equally to the second, the third, the 100th, the 1000th. Eventually, inevitably, you reach a point where only a few grains remain, then only 2, then only 1. Finally, your hand hovers over the last remaining grain of sand. According to the logic you have been following, this lone grain must still constitute a heap because you arrived at it by a series of steps, each of which preserved the heapness of what remained. But now the absurdity becomes undeniable. A single grain of sand cannot be a heap, no matter what logical journey brought you to that conclusion. One grain lacks every quality we associate with heapness: accumulation, substantial size, the sense of multiple parts gathering into a whole. If language means anything at all, a single grain simply is not a heap. This is the heart of the Sorites paradox, named after the Greek word soros, meaning heap. It was first formulated by the ancient philosopher Eubulides of Miletus, a contemporary and intellectual rival of Aristotle. The paradox reveals a fundamental problem with concepts that seem to involve gradual change or vague boundaries. It shows how impeccable logic, applied step by step, can lead us from obvious truth to obvious falsehood. The puzzle extends far beyond heaps of sand. Consider the concept of baldness. A person with a full head of hair is clearly not bald. If we remove one hair from their scalp, they remain clearly not bald. The loss of a single hair cannot transform a non-bald person into a bald one. Yet if we continue removing hairs one by one, eventually we must reach a point where the person is undeniably bald. But when exactly does this transformation occur? After which particular hair is removed, does baldness suddenly appear? Or consider the aging process. A newborn baby is certainly young. A day later, the baby is still young. One day cannot make the difference between youth and old age. A week later, still young. A month later, still young. Yet, if we continue this reasoning throughout a human lifetime, we would conclude that even a person celebrating their 100th birthday must still be young, since no single day can mark the boundary between youth and old age. The paradox reveals something profound about the nature of language and concepts. Many of the words we use every day, tall, short, rich, poor, hot, cold, fast, slow, seem to resist precise definition. They exist in a world of degrees and gradations where boundaries are fuzzy and context dependent. A temperature that feels hot in winter might feel cool in summer. A speed that seems fast for a bicycle might seem slow for an airplane. These vague concepts, which philosophers call Sorites susceptible, appear to be essential to how we navigate and understand the world. We constantly make judgments about things being more or less similar, bigger or smaller, better or worse. Our language is filled with comparative and evaluative terms that lack precise boundaries. Yet the Sorites paradox suggests that this very vagueness creates logical problems that may be impossible to resolve. One attempted solution involves the idea of precise boundaries that we simply cannot detect. Perhaps there is an exact number of grains that defines the minimum heap, an exact number of hairs that marks the boundary between bald and non-bald, an exact age at which youth becomes old age. We cannot perceive these boundaries because our senses and cognitive abilities are limited, but they exist nonetheless as objective features of reality. This solution preserves classical logic by insisting that every proposition must be either true or false, that every boundary must be sharp and well defined. A person is either bald or not bald with no middle ground. A collection of sand is either a heap or not a heap, with no ambiguous cases. The vagueness we experience is merely a limitation of our knowledge, not a feature of reality itself. Yet this solution comes at a considerable cost. It requires us to believe that removing one specific grain of sand from a heap of 10,000 grains transforms it from a heap into a non-heap, even though the change is completely imperceptible. It suggests that there are objective, precise boundaries in nature corresponding to our vague concepts, boundaries that seem to have no basis in the physical or psychological processes that give rise to these concepts. Another approach embraces vagueness as a fundamental feature of language and thought. From this perspective, concepts like heap and bald are inherently imprecise, designed to capture rough distinctions rather than exact boundaries. There is no precise number of grains required for a heap because heapness is not that kind of property. Instead, there are clear cases of heaps, clear cases of non-heaps, and borderline cases that resist classification. This solution allows for three-valued logic instead of the classical two-valued system. In addition to true and false, propositions can be indeterminate or neither true nor false. This collection of sand is a heap might be true for 10,000 grains, false for 1 grain, and indeterminate for some number in between. The paradox dissolves because we reject the assumption that every statement must have a definite truth value. But this approach raises its own puzzles. If concepts can be vague, how do we communicate effectively? How can we make reliable inferences if our reasoning involves indeterminate propositions? The precision that classical logic provides seems necessary for mathematics, science, and rational discourse generally. Abandoning it might solve the Sorites paradox but create more problems than it solves. Some philosophers have suggested that the paradox reveals the context-dependent nature of our concepts. Whether a collection of sand counts as a heap might depend on the circumstances in which the question arises. In a sandbox, 50 grains might constitute a heap relative to the scale of play. On a beach, it might take millions of grains to qualify. The concept of heap does not have fixed boundaries, but rather flexible ones that adjust to the context of use. This pragmatic approach emphasizes the functional role of concepts in human communication and action. We use the word heap not to track some precise property in nature, but to make useful distinctions in particular situations. The concept succeeds when it helps us communicate effectively and fails when it leads to confusion or misunderstanding. From this perspective, the Sorites paradox arises when we take concepts out of their practical contexts and treat them as if they had precise, universal definitions. The paradox also connects to fundamental questions about the nature of identity and change over time. Consider a person who gradually loses weight over several years. At what point do they transition from being overweight to being normal weight to being underweight? The physical process is continuous and gradual, but our concepts seem to demand discrete categories. This problem extends to personal identity itself. You are constantly changing. Your cells are replaced. Your memories fade and form. Your personality evolves. Yet you maintain a sense of continuous identity throughout these changes. The Sorites paradox suggests that this sense of stable identity might be as problematic as the concept of a heap. At what point, if any, do you stop being the same person you were yesterday, last year, or in childhood? The paradox also illuminates the relationship between individual and collective properties. A heap is not just a collection of grains, but a collection with a particular organizational structure. The grains must be arranged in roughly the same location, piled up rather than scattered. This raises questions about emergence, how collective properties arise from the relationships between individual components. Similar questions arise in other domains. When does a collection of people become a crowd? When does a group of musicians become an orchestra? When does a gathering of cells become an organism? These transitions seem to involve not just numerical thresholds, but also organizational complexity, functional integration, and emergent properties that cannot be reduced to simple counts of individual components. The digital age has given new relevance to the Sorites paradox. Computer systems typically require precise definitions and sharp boundaries. Digital images are composed of discrete pixels, digital sounds are sampled at regular intervals, and computer programs operate through discrete logical steps. Yet these discrete systems must somehow capture and represent the continuous vague phenomena of human experience. Machine learning systems face similar challenges. When does a computer program become intelligent? When does an artificial neural network develop consciousness? These questions echo the ancient puzzle of the heap, suggesting that the boundary between artificial and natural intelligence might be as vague as the boundary between heap and non-heap. The paradox also raises questions about moral and legal boundaries. Criminal justice systems must often determine precise ages of responsibility, specific thresholds for legal competence, and exact boundaries for self-defense or mental illness. Yet the human qualities these boundaries attempt to capture, maturity, competence, sanity, seem to admit of degrees rather than sharp divisions. Environmental policy faces similar challenges. When does climate change become dangerous? When does a species become endangered? When does pollution become harmful? These questions require drawing precise lines in domains where nature provides only gradual transitions and continuous variation. Perhaps the deepest insight offered by the Sorites paradox is its revelation that the relationship between language and reality is far more complex than we typically assume. Our words and concepts evolved to help us navigate a world of medium-sized objects and practical concerns. When we extend these concepts to their logical limits, we discover that they may not be equipped to handle the extreme cases that pure logic can construct. This does not necessarily mean that our concepts are flawed or that logic is unreliable. Instead, it might mean that we need more nuanced ways of understanding how language relates to reality, how reasoning works with vague concepts, and how communication succeeds despite the inherent imprecision of many of our most important words. When you next encounter a heap of sand on a beach, or notice someone gradually going bald, or consider the slow process of aging, you might remember this ancient puzzle. You might reflect on the mysterious boundaries that seem to exist everywhere in human experience. Boundaries between colors in a sunset, between musical notes in a melody, between waking and sleeping in the gentle transition toward dreams. The grains of sand continue their eternal accumulation and dispersal along the shores of human thought, gathering into heaps that resist precise definition, dispersing into collections that challenge our concepts. In their shifting patterns lies encoded one of the most fundamental questions about the nature of language, logic, and the relationship between discrete and continuous aspects of reality. The paradox reminds us that even our most basic concepts may contain complexities that emerge only when we push them to their limits, and that the precision we often seek may be neither possible nor necessary for navigating the beautifully imprecise world in which we live. The Ship of Theseus paradox. Picture: a magnificent vessel resting in the harbor of ancient Athens, its bronze-fitted hull gleaming in the Mediterranean sun. This is no ordinary ship, but one that carries within its wooden bones the weight of legend and the dreams of a civilization. The Athenians called it the Ship of Theseus, named for their great hero who had sailed to Crete, navigated the deadly labyrinth, slain the monstrous Minotaur, and returned home victorious with the children who had been destined for sacrifice. The ship itself had become sacred, a floating monument to courage and triumph. Its black sails, which Theseus had forgotten to change to white in his excitement at homecoming, had caused his father's tragic death. But the vessel that bore those sails had brought salvation to Athens, and the grateful citizens preserved it with reverential care. They designated it for annual voyages to the sacred island of Delos, carrying offerings and prayers to Apollo in commemoration of their deliverance. For years, the ship sailed faithfully on its sacred mission. But time, that patient destroyer of all things, began to work its slow alchemy upon the wooden vessel. The salt air corroded the bronze fittings, storms battered the hull. The constant working of timber against timber, rope against wood, metal against metal gradually wore down the ship's components. Some planks began to rot, requiring replacement. Rigging frayed, and needed renewal. Even the mighty mast that had once carried Theseus safely home eventually showed signs of weakness and had to be changed. The Athenians faced these repairs with careful attention to tradition. When they replaced a rotting plank, they chose timber that matched the original as closely as possible. When they renewed a piece of rigging, they used the same knots, the same materials, the same methods their predecessors had employed. Each replacement was made with loving precision, as if they were not merely maintaining a ship, but preserving the very essence of their heroic past. As decades passed, the repairs became more frequent and more extensive. A section of the hull here, a portion of the deck there, pieces of the sail, lengths of rope, bronze fittings green with age. The ship's caretakers worked with meticulous care, ensuring that each new component fit perfectly with the old, that the vessel's appearance and function remained unchanged. To any observer, this was still unmistakably the ship of Theseus, still the same sacred vessel that had carried their hero to victory. But then one day, a philosopher named Plutarch posed a question that would echo through the centuries and challenge our most basic assumptions about identity and change. After so many repairs and replacements, he asked, was this still truly the same ship that Theseus had sailed? When every plank had been replaced, when every rope had been renewed, when every fitting had been changed, when nothing of the original material remained. Could the Athenians honestly claim that this was still the ship of their hero? This question cuts to the heart of one of philosophy's most enduring puzzles. What makes something the thing it is? What allows us to say that an object remains the same object even as it changes over time? The ship in the harbor looked the same, functioned the same, carried the same sacred significance. It followed the same route to Delos, served the same religious purpose, inspired the same reverence. In every way that mattered to the Athenians, it was the ship of Theseus. Yet something seemed to have changed in a fundamental way. If you could gather all the original planks, all the original ropes and fittings, all the components that had been replaced over the years, would that collection of ancient wood and bronze be more authentically the ship of Theseus than the vessel that now sailed to Delos? Or would both have equal claim to the identity, leaving us with the impossible situation of one ship that had somehow become two? The puzzle deepens when we consider a variation proposed by the philosopher Thomas Hobbes. Imagine that the Athenians, in their reverence for tradition, had carefully preserved every piece they removed from the ship. The rotting planks were treated and stored, the frayed ropes were cleaned and coiled, the corroded fittings were polished and catalogued. Over time, these preserved components accumulated until someone conceived the idea of reassembling them into their original configuration. Now we have two ships. One is the vessel that has continued sailing to Delos, composed entirely of new materials but maintaining perfect continuity of function and form. The other is a ship reassembled from all the original components that Theseus himself had touched, but which has sat idle for decades while its parts were slowly gathered and restored. Which one is truly the ship of Theseus? Which has the stronger claim to the identity of that legendary vessel? Our intuitions pull us in different directions. The ship that has continued in service seems to have the stronger claim. It has maintained an unbroken chain of existence, serving its sacred purpose without interruption. Like a flame passed from one torch to another, its identity has been preserved through continuity of function even as its material substance has changed. But the ship made from original components has a different kind of authenticity. These are the very planks that Theseus stood upon, the actual ropes that his hands pulled, the real bronze that caught the Mediterranean sun during that heroic voyage. If identity resides in material substance rather than functional continuity, then surely this reassembled vessel has the stronger claim to be the true ship of Theseus. The paradox reveals fundamental questions about the nature of identity over time. Consider your own body, which faces the same puzzle as Theseus's ship. The cells that compose you are constantly being replaced. Skin cells slough off and regenerate, blood cells are renewed, even brain cells are gradually replaced over the course of your lifetime. After 7 years, very few of the atoms that currently make up your body were part of you 7 years ago. In what sense are you the same person you were then? Yet clearly you maintain a continuous identity through all these material changes. Your memories connect you to your past, your personality remains recognizably yours, your relationships and commitments extend across time. The psychological and social continuity seems more important than material continuity in establishing personal identity. You are not just a collection of atoms, but a pattern of information, experience, and relationship that persists even as its physical substrate changes. This suggests one approach to the ship of Theseus paradox. Perhaps identity resides not in material components but in patterns, structures, and functions. The ship of Theseus is defined not by its particular planks and ropes, but by its design, its purpose, its role in Athenian culture. As long as these patterns are preserved, the identity persists regardless of material changes. But this functional approach raises puzzles of its own. If identity resides in pattern and function, then presumably any ship built to the same specifications and serving the same purpose would have equal claim to be the ship of Theseus. We could build a dozen identical vessels and all would be equally authentic. This seems to drain the concept of identity of any meaningful content. Another approach emphasizes causal continuity. The ship that has continued sailing to Delos has an unbroken causal chain connecting it to the original vessel. Each plank was replaced by a new plank that took over its exact function, each rope by a new rope that served the same purpose. The identity flows through these causal connections like water flowing through a channel, maintaining its course even as its substance changes. The reassembled ship, by contrast, lacks this causal continuity. Its components were removed from active service, stored separately, and then artificially brought back together. The causal chain was broken when the parts were taken out of service, and mere physical resemblance to the original cannot restore what was lost. Yet even causal continuity has its limits. If the ship were destroyed in a storm and then rebuilt from memory by craftsmen who had never seen the original, would it still be the ship of Theseus? What if it were transported piece by piece to another harbor and then reassembled? At what point does causal continuity become so attenuated that identity is lost? The paradox also illuminates questions about the relationship between objects and their histories. Part of what makes the ship of Theseus special is not just its physical properties, but its historical significance. It carried Theseus on his heroic mission, participated in the salvation of Athens, became a sacred symbol of triumph over adversity. These historical properties seem essential to the ship's identity in ways that mere physical or functional properties are not. But how do objects carry their histories with them? If the ship's historical significance resides in its connection to past events, then replacing its components might sever those connections. The new planks have no history of sailing to Crete, no experience of the labyrinth, no participation in the victory over the Minotaur. In what sense can they be said to inherit the historical properties of the components they replaced? This question becomes even more complex when we consider the role of collective memory and social recognition. The ship of Theseus is not just a physical object, but a cultural institution, a focus for community identity and religious observance. Its meaning resides partly in how the Athenians understand and relate to it. If they collectively agree that the continuously maintained vessel is the true ship of Theseus, does their social recognition create or merely acknowledge its identity? Modern technology gives new dimensions to the paradox. Consider a digital photograph that is repeatedly copied, compressed, and enhanced. Each processing step might change some pixels while preserving others. Eventually, none of the original data might remain, yet the image might still be recognizably the same photograph. The digital realm seems to support the pattern-based approach to identity. What matters is not the particular bits of data, but the information they encode. But digital copying also allows for perfect duplication in ways that physical objects cannot. If we copy a digital file, we get two files with equal claim to the identity of the original. This suggests that identity in the digital realm might be fundamentally different from identity in the physical world, where objects cannot be perfectly duplicated. The paradox also connects to questions about natural kinds and artifacts. The ship of Theseus is clearly an artifact created by human design for human purposes. Its identity seems bound up with its function and cultural significance in ways that might not apply to natural objects. A mountain that loses rocks to erosion and gains new material from volcanic activity might maintain its identity in different ways than a ship that has its planks replaced. Yet even natural objects face versions of the same puzzle. A river maintains its identity despite the constant flow of water through it. A forest remains the same forest even as individual trees die and are replaced. These examples suggest that the ship of Theseus paradox might reveal something fundamental about identity in general, not just about artifacts. The ecological perspective offers another lens through which to view the paradox. In nature, identity often emerges at the level of systems rather than components. An ecosystem maintains its character through dynamic equilibrium, with energy and matter flowing through it while overall patterns remain stable. The ship might be understood as a similar kind of system, maintaining its identity through the dynamic process of maintenance and repair. Personal identity takes on new complexity in light of the paradox. If you are like the ship of Theseus, constantly replacing your material components while maintaining psychological continuity, then questions arise about responsibility, achievement, and relationship. Are you responsible for actions performed by previous versions of yourself with different physical compositions? Do your accomplishments belong to you or to the person who shared your name but had different atoms? The paradox also illuminates questions about restoration and authenticity in art and architecture. When the Sistine Chapel is cleaned and restored, when ancient buildings are reconstructed from fragments, when historical artifacts are conserved with modern materials, what exactly is being preserved? The ship of Theseus paradox suggests that these questions about cultural preservation have no easy answers. Perhaps the deepest insight offered by the paradox is its revelation that identity is not a simple, unitary concept, but a complex phenomenon that operates differently in different contexts. Physical identity, functional identity, causal identity, historical identity, and social identity might all be relevant to understanding what makes something the thing it is. The ship of Theseus forces us to consider which of these aspects we prioritize and why. The paradox also reminds us that identity is not just a philosophical abstraction, but a practical concern that affects how we understand ownership, responsibility, authenticity, and value. Legal systems must determine when a rebuilt vehicle is still the same vehicle for insurance purposes, when a restored artwork is still the original for purposes of attribution, when a renewed contract is still the same agreement for enforcement purposes. As you move through your own life, constantly changing yet somehow remaining yourself, you might remember the ancient ship that sailed to Delos. You might reflect on the mysterious continuity that connects your present self to your past selves. The patterns that persist through all the material changes your body undergoes, the threads of memory and meaning that weave together to create the narrative of your identity. The ship of Theseus continues its eternal voyage through the harbor of human thought, simultaneously the same and different, one and many, original and copy. Its planks have been replaced countless times by countless thinkers, each bringing new materials to the ancient structure while trying to preserve its essential meaning. Yet somehow, through all these intellectual renovations, the paradox maintains its identity as one of philosophy's most enduring puzzles. In its weathered hull lies encoded questions that touch the very foundations of selfhood, continuity, and change. The ship reminds us that identity is not a fixed property but an ongoing achievement, not a static state but a dynamic process, not a simple fact but a complex story that we tell about the relationship between past and present, between what changes and what endures, between the material and the meaningful in our ever-changing world. The liar paradox picture. A simple sentence written on a piece of paper, nothing more than 5 words arranged in the most ordinary way. The handwriting is clear, the grammar is perfect, the meaning seems transparent. Any reader of English would understand it immediately. There are no obscure words, no complex ideas, no hidden references to ancient philosophy or modern science. It appears to be the kind of straightforward statement that presents no challenge to comprehension, no puzzle for the mind to solve. The sentence reads, "This sentence is not true." At first glance, this seems like a perfectly reasonable claim that someone might make about a particular sentence. Perhaps they are correcting a previous statement, or pointing out an error in logic, or simply expressing disagreement with something that has been written. The sentence appears to follow all the normal rules of language and meaning. It has a subject, this sentence, and a predicate, is not true. It makes a clear assertion about the truth value of a particular linguistic entity. But something strange happens when we attempt to determine whether this sentence is actually true or false. This is not usually a difficult task. Most sentences present us with claims about the world that we can evaluate through observation, reasoning, or reference to established facts. The sky is blue can be verified by looking upward on a clear day. 2 + 2 = 4 can be confirmed through mathematical reasoning. Shakespeare wrote Hamlet can be established through historical evidence. But our simple sentence creates a logical trap that seems impossible to escape. Let us approach it with the confidence of rational beings who believe that every statement must be either true or false, that reality has a definite structure, and that language serves to describe this structure accurately. Suppose first that the sentence is true. If this sentence is not true is indeed a true statement, then what it claims must be the case. But what does it claim? It asserts that this very sentence, the one we are now evaluating, is not true. So if the sentence is true, then according to its own content, it is not true. We have arrived at a contradiction. The sentence is both true and not true simultaneously. Perhaps then the sentence is false. If this sentence is not true is a false statement, then what it claims must not be the case, but the sentence claims that it is not true. If this claim is false, then the sentence must actually be true. So if we assume the sentence is false, we are forced to conclude that it is true. Again, we reach a contradiction. The sentence is both false and true at the same time. Every path of reasoning leads us to the same impossible destination. The sentence seems to be true if and only if it is false, and false if and only if it is true. It appears to violate the most basic principle of logic, the law of non-contradiction, which holds that nothing can be both true and false in the same respect at the same time. This is the essence of the liar paradox, one of the oldest and most persistent puzzles in the history of human thought. It was known to the ancient Greeks, discussed by medieval scholars, and continues to challenge logicians, philosophers, and computer scientists today. The paradox seems to emerge from nothing more than ordinary language and basic logical reasoning, yet it creates contradictions that threaten the foundations of rational discourse. The ancient origins of the paradox trace back to the island of Crete and a philosopher named Epimenides, who lived in the 6th century before our era. Epimenides was himself a Cretan, and he allegedly made the claim that all Cretans are liars. If we interpret this as meaning that Cretans always speak falsely, then Epimenides, being a Cretan, must have spoken falsely when he made this claim. But if his claim was false, then it cannot be true that all Cretans are liars, which would mean that at least some Cretans speak truly, perhaps including Epimenides himself when he made this very statement. The modern, more direct form of the paradox strips away the cultural references and historical context to reveal the logical core of the problem. "This sentence is not true" creates the same self-referential loop without requiring any knowledge of Greek geography or the character of Cretan culture. It is a pure distillation of the logical contradiction that arises when language turns in upon itself. The paradox reveals something profound about the relationship between language and truth. We ordinarily think of sentences as vehicles for conveying information about the world beyond language. "The cat is on the mat" tells us about the spatial relationship between a particular feline and a particular piece of fabric. "The temperature is rising" informs us about atmospheric conditions. Even abstract statements like "justice is important" or "beauty is subjective" seem to make claims about values, concepts, or the nature of human experience. But the liar sentence does something different. Instead of pointing outward to the world beyond language, it points inward to itself. It is self-referential in the most direct possible way, making a claim about its own truth value. This self-reference creates a closed loop of meaning that seems to trap logic in an endless cycle of contradiction. The paradox raises fundamental questions about the nature of truth itself. We normally think of truth as a relationship between language and reality. A sentence is true if what it describes corresponds to how things actually are in the world. But what happens when a sentence describes not the external world, but its own truth value? What reality could the liar sentence correspond to or fail to correspond to? Some philosophers have argued that the paradox reveals the limitations of our ordinary concept of truth. Perhaps truth is not a property that can be meaningfully attributed to all sentences. Just as we would not ask about the color of the number 7 or the weight of a musical note, perhaps we should not ask about the truth value of self-referential sentences like "the liar." This approach treats the liar sentence as a category error, a misuse of language that creates the illusion of meaningful statement while actually saying nothing at all. From this perspective, the sentence, "This sentence is not true," is neither true nor false, but simply meaningless, like a grammatically correct but semantically empty string of words. Others have proposed that we need to develop more sophisticated theories of truth that can handle self-reference without falling into contradiction. The mathematician and logician Alfred Tarski, for instance, argued that we must distinguish between different levels of language. Object language is used to talk about the world, while meta-language is used to talk about the object language. Truth, Tarski argued, can only be properly defined at the meta-linguistic level. According to Tarski's approach, when we say "this sentence is not true," we are attempting to make a meta-linguistic claim about a sentence while using that very sentence to make the claim. This confusion of linguistic levels creates the paradox. If we maintain strict separation between levels, the paradox cannot arise because sentences cannot meaningfully refer to their own truth values. But Tarski's solution comes at a cost. It seems to eliminate the possibility of natural language making claims about its own truth conditions, something that we do regularly in ordinary discourse. When someone says, "What I just told you is false," or "Don't believe a word I'm saying," they seem to be engaging in perfectly meaningful self-reference. Tarski's solution might resolve the logical paradox, but at the price of declaring large portions of natural language to be meaningless. Another approach embraces the contradictions as revealing something fundamental about the nature of reality itself. Some philosophers have argued that reality is inherently contradictory and that classical logic, with its insistence on non-contradiction, fails to capture the true complexity of existence. From this perspective, the liar paradox does not represent a problem to be solved, but a window into the paradoxical nature of truth itself. This dialectical approach finds echoes in Eastern philosophy, where contradictions are sometimes seen not as logical errors, but as pointers toward deeper truths that cannot be captured in ordinary conceptual language. The liar sentence might be understood as a kind of logical koan, a puzzle designed to short-circuit normal reasoning and point toward insights that transcend rational discourse. The digital age has given new relevance to the liar paradox. Computer systems must handle self-referential statements and recursive procedures, and programmers have discovered that careless self-reference can create infinite loops that crash programs or consume unlimited computational resources. The paradox reveals potential instabilities in any formal system that allows unrestricted self-reference. Artificial intelligence systems face similar challenges. If we want to create machines that can reason about their own reasoning, make statements about their own statements, or evaluate the truth of their own claims, we must somehow solve or circumvent the problems revealed by the liar paradox. The paradox serves as a warning about the dangers of unlimited self-reference in computational systems. The paradox also connects to questions about consciousness and self-awareness. Human consciousness seems to involve a kind of self-reference. We are aware that we are aware, we think about our own thinking, we observe our own mental states. If self-reference inevitably leads to logical contradictions, how is conscious self-awareness possible at all? Some philosophers have suggested that consciousness might be fundamentally paradoxical, involving the same kind of strange loops that create the liar paradox. The self might be a kind of logical impossibility that somehow manages to exist anyway, creating the illusion of unified experience from what is actually a collection of contradictory processes. The paradox also raises questions about the relationship between truth and meaning. If the liar sentence cannot be consistently assigned a truth value, what does this tell us about its meaning? Can a sentence be meaningful, yet neither true nor false? Or does meaningfulness require the possibility of truth evaluation? These questions connect to broader issues in the philosophy of language about the relationship between semantic content and truth conditions. Some theories hold that the meaning of a sentence just is its truth conditions, the set of circumstances under which it would be true. If the liar sentence has no coherent truth conditions, then perhaps it has no meaning either. But this seems counterintuitive. The liar sentence appears to be perfectly meaningful. We understand what it claims, we can explain it to others, we can see why it creates logical problems. The fact that it generates contradictions might not eliminate its meaning, but might instead reveal aspects of meaning that cannot be captured through truth-conditional semantics alone. The paradox also illuminates the relationship between logic and ordinary language. Classical logic assumes that every proposition is either true or false, that contradictions cannot be true, and that from a contradiction anything follows. But natural language seems to allow for meaningful statements that violate these principles. People regularly use self-referential language, make contradictory claims, and reason in ways that would be invalid according to classical logic. Yet communication generally succeeds, and we manage to coordinate our actions and share information despite these apparent logical flaws. Perhaps the liar paradox reveals not a flaw in language, but a limitation of classical logic as a tool for understanding linguistic meaning. Some logicians have developed alternative logical systems that allow for contradictions without complete logical collapse. Paraconsistent logics permit contradictory statements to be true simultaneously without thereby making every statement true. Relevance logics restrict the principle that anything follows from a contradiction by requiring relevant connections between premises and conclusions. These alternative logics suggest that the liar paradox might be resolved not by eliminating self-reference or declaring it meaningless, but by developing more flexible approaches to reasoning about contradictory information. Perhaps contradictions are not always signs of error, but sometimes indicators that our logical systems need refinement. The paradox also raises questions about the nature of knowledge and belief. If someone asserts the liar sentence, what attitude should we take toward their claim? We cannot believe it to be true without contradiction, but we cannot believe it to be false without contradiction either. Should we suspend judgment? But even suspension of judgment seems problematic, since it suggests that there is some fact of the matter about which we are remaining neutral. This epistemic dimension of the paradox connects to broader questions about how we should respond to contradictory information, unresolvable disputes, and claims that seem to undermine themselves. The liar paradox becomes a test case for theories of rational belief revision and epistemic virtues. Perhaps the deepest insight offered by the liar paradox is its revelation that language is more powerful and more dangerous than we typically recognize. The ability to refer to ourselves, to make claims about our own claims, to think about our own thinking, creates possibilities for both creativity and contradiction that are built into the very structure of meaningful discourse. The paradox reminds us that every act of communication involves risks of misunderstanding, contradiction, and logical instability. Yet these same risks are inseparable from the creative potential of language to generate new meanings, to reflect upon itself, and to push beyond the boundaries of established truth. When you encounter statements that seem to refer to themselves, whether in philosophy, literature, humor, or everyday conversation, you might remember the simple sentence that has puzzled thinkers for over 2 millennia. You might reflect on the mysterious capacity of language to turn inward upon itself, creating loops of meaning that both illuminate and confound our understanding. The liar sentence continues its eternal dance between truth and falsity in the landscape of human thought, neither true nor false, but somehow meaningful nonetheless. It reminds us that language is not simply a transparent window onto reality, but a complex system with its own internal dynamics, its own creative possibilities, and its own potential for paradox. In its impossible claim lies encoded one of the most fundamental questions about the relationship between language, thought, and truth. The sentence that devours itself becomes a mirror reflecting back the deepest puzzles about meaning, reference, and the strange loops through which consciousness knows itself and language speaks about its own speaking. The crocodile paradox. Along the muddy banks of the ancient Nile, where papyrus reeds whisper secrets to the passing water, and the sun casts long shadows across the fertile delta, there lived a crocodile unlike any other in the long annals of predator and prey. This was no ordinary creature driven by simple hunger or territorial instinct. This crocodile possessed something far more dangerous than powerful jaws or armored hide. It possessed the capacity for reason, the ability to make promises, and a peculiar sense of honor that would prove more treacherous than any physical threat. One sweltering afternoon, as the river ran slow and thick with silt, a father came to the water's edge to fill his clay vessel. Behind him played his young child, a boy of perhaps 5 years, innocent of the world's dangers and delighted by the dancing insects that hovered over the warm mud. The father worked quickly, knowing that the river held perils, but in a moment of distraction. Perhaps watching a bird take flight, or thinking of the work that awaited him at home. He looked away. In that instant the crocodile struck, with the lightning speed of its kind, but instead of delivering the swift end that nature usually provides, the beast did something extraordinary. It held the child gently but firmly in its massive jaws, alive and unharmed, and spoke to the terrified father in words that carried the weight of ancient wisdom and terrible logic. "Your child is safe for now," the crocodile said, its voice carrying across the water with the authority of ages. "I will make you a bargain, a test of wit and wisdom. I will ask you to predict what I will do next. If you can correctly guess my intention, I will return your child unharmed, but if you guess incorrectly, I will keep the child forever." The father's mind raced through possibilities, searching for some strategy that might save his beloved child. The crocodile seemed to be offering a fair chance, a 50-50 proposition where careful reasoning might tip the scales in his favor. Perhaps he could read something in the creature's eyes, detect some tell in its manner, find some clue that would reveal its true intentions. After long moments of agonized thought, the father spoke his answer with the desperate hope of a parent whose world hung in the balance. "You will not return my child to me." Now the crocodile fell silent, and in that silence lay a trap more cunning than any that nature had devised. The beast found itself caught in a web of logic that had no clean resolution, a paradox that threatened to make any action impossible. Consider the crocodile's dilemma from the perspective of ancient logic. The father has predicted that the crocodile will not return the child. According to the original bargain, if this prediction is correct, then the crocodile must return the child. But if the crocodile returns the child, then the father's prediction that the child would not be returned turns out to be false. And if the prediction is false, then according to the bargain, the crocodile should not return the child. But what if the crocodile chooses not to return the child? This would make the father's prediction true, since the father had predicted exactly this outcome. And if the prediction is true, then the crocodile is bound by its promise to return the child. Yet returning the child would once again make the prediction false, creating the same logical loop that seemed to have no exit. This is the heart of the crocodile paradox, a puzzle that emerged from ancient Greek philosophy to challenge our understanding of promises, predictions, and the relationship between language and action. Like the liar paradox, it creates a self-referential situation where any attempt to resolve the logical contradiction leads directly back to the same contradiction. The paradox reveals something profound about the nature of conditional promises and the problems that arise when the condition for fulfilling a promise depends on the accuracy of a prediction about whether the promise will be fulfilled. The crocodile's bargain seems fair on the surface. It offers the father a genuine chance to save his child through correct reasoning. Yet the specific prediction the father makes transforms the simple contract into an impossible logical knot. What makes this paradox particularly fascinating is that it emerges not from abstract logical reasoning but from a concrete narrative situation involving real stakes and genuine human emotions. The father's love for his child, the crocodile's promise, the child's fate. These give the logical problem an emotional weight that pure logical puzzles often lack. We find ourselves caring not just about the resolution of the contradiction, but about the outcome for the characters involved. The paradox also illuminates the relationship between intention and action, between what we plan to do and what we actually do. The crocodile must form an intention about whether to return the child, but the correctness of the father's prediction depends on what the crocodile actually does, not on what it intends to do. This creates a temporal puzzle where the crocodile's future action determines the truth value of the father's present prediction, which in turn determines what the crocodile should do in the future. From the crocodile's perspective, the paradox reveals the dangers of making promises whose fulfillment depends on conditions that are themselves affected by the promise. The creature thought it was offering a straightforward intellectual challenge, but the father's cleverness has transformed it into something far more complex. The crocodile finds itself trapped not by physical constraints but by the logical implications of its own words. This connects to broader questions about the relationship between promises and predictions in human life. When we promise to do something contingent on certain conditions, we assume that those conditions can be evaluated independently of our promise. But the crocodile paradox shows that self-referential conditions can create logical instabilities that make it impossible to determine whether the conditions have been met. Consider analogous situations in human experience. A teacher might promise a student, "If you can correctly predict whether I will give you an A in this course, then I will give you an A." If the student predicts, "You will not give me an A," then the same paradox emerges. The prediction cannot be evaluated without knowing the teacher's action, but the teacher's action depends on whether the prediction is correct. Legal contracts sometimes face similar problems when they include conditions that depend on predictions about the contract's own fulfillment. Insurance policies, warranty agreements, and conditional sales can create situations where determining whether conditions have been met requires knowing what actions will be taken in response to those very conditions. The paradox also raises questions about the nature of rational choice and decision-making. If the crocodile is a perfectly rational agent, what should it do when faced with this logical contradiction? Some philosophers argue that rational agents cannot find themselves in genuinely paradoxical situations, that the appearance of paradox indicates either an error in reasoning or an impossible scenario that could never actually arise. From this perspective, the crocodile paradox reveals the incoherence of the original bargain. A truly rational crocodile would never make a promise that could lead to logical contradiction. The paradox emerges because we have imagined an impossible scenario. Not impossible in terms of talking crocodiles or miraculous events, but impossible in terms of the logical structure of rational promising. Others argue that the paradox shows the limitations of classical logic when applied to real-world situations involving agents, promises, and time. Perhaps the crocodile should adopt a different approach to reasoning that can handle the self-referential aspects of the situation without falling into contradiction. One proposed solution involves temporal considerations. Perhaps the crocodile's intention must be formed before hearing the father's prediction, making the prediction either correct or incorrect based on a pre-existing plan. From this perspective, the father's statement is simply a guess about what the crocodile had already decided to do, and the apparent paradox dissolves into a straightforward question of whether the guess was accurate. But this solution seems to drain the scenario of its essential character. The crocodile's promise suggests that it will decide what to do based on the accuracy of the father's prediction, not that it has already decided and is merely testing the father's psychic abilities. The temporal solution eliminates the paradox, but only by changing the fundamental nature of the situation. Another approach focuses on the pragmatic aspects of promising and prediction. In real-world contexts, promises and predictions serve specific communicative functions that go beyond their purely logical content. The crocodile's promise is presumably meant to give the father a fair chance to save his child, while the father's prediction is meant to demonstrate his reasoning ability, or perhaps to find a clever loophole in the bargain. From this pragmatic perspective, the father's prediction might be seen as a refusal to play the game by its intended rules. Instead of trying to genuinely guess what the crocodile will do, the father has chosen a prediction that makes the game impossible to play. Perhaps the crocodile should respond by rejecting the father's answer as violating the spirit of the original bargain. But this raises questions about what the spirit of the bargain actually requires. The crocodile set the explicit rule that correct predictions would be rewarded and incorrect predictions punished. The father has followed this rule exactly, offering a prediction that can be evaluated for correctness. If the crocodile wanted to exclude certain types of predictions, it should have specified those exclusions in advance. The paradox also illuminates the relationship between logical reasoning and moral responsibility. If the crocodile is genuinely committed to honoring its promise, then it faces a moral dilemma as well as a logical one. Breaking its word would violate whatever ethical code led it to make the promise in the first place, yet honoring the promise seems logically impossible. This moral dimension adds complexity to the paradox that pure, logical puzzles typically lack. We might feel that the crocodile deserves to be trapped by its own words, that its attempt to create a life-or-death intellectual game was morally questionable from the beginning. The father's clever response might be seen as poetic justice rather than logical trickery. From the child's perspective, the paradox creates a situation where their fate depends not on their own actions or on simple chance, but on the resolution of an abstract logical puzzle. This seems to violate basic intuitions about justice and desert. The child has done nothing to deserve their predicament, yet their future depends on philosophical reasoning that they could not possibly understand. The paradox also connects to questions about the nature of language and meaning in high-stakes situations. The crocodile and the father are using language to make promises and predictions, but they are also using it to engage in a kind of intellectual combat where words become weapons. The father's prediction is simultaneously a statement about the future and a strategic move in a life-or-death game. This dual function of language, as both descriptive tool and strategic instrument, creates ambiguities that contribute to the paradox. When the father says, "You will not return my child," is he making a genuine prediction about the crocodile's future behavior? Or is he making a calculated move in a logical game? The answer might affect how we interpret the crocodile's obligation to honor its promise. Modern game theory offers another lens through which to view the paradox. The crocodile and the father are engaged in a strategic interaction where each party's optimal choice depends on what the other party chooses. The father's prediction creates a situation where there is no stable equilibrium, no consistent way for both parties to choose strategies that are optimal responses to each other. From this game-theoretic perspective, the paradox reveals the instability that can arise in strategic situations involving self-reference and circular dependencies. The father has essentially forced the game into a state where no rational solution exists, making it impossible for either party to determine their optimal strategy. The storytelling aspect of the crocodile paradox also deserves attention. Unlike purely abstract logical puzzles, this paradox is embedded in a narrative framework that gives it dramatic structure and emotional resonance. The story format makes the logical problem more accessible and memorable, but it also raises questions about the relationship between narrative coherence and logical consistency. Can a story contain a genuine logical contradiction while remaining meaningful as a story? The crocodile paradox suggests that narratives might be able to accommodate paradoxes in ways that formal logical systems cannot. The story continues to engage our interest and concern even when the logical structure breaks down, suggesting that meaning and coherence might not depend entirely on logical consistency. Perhaps the deepest insight offered by the crocodile paradox is its revelation of the complex relationships between promises, predictions, intentions, and actions in situations involving multiple rational agents. The paradox shows how self-reference can destabilize even simple interactive situations, creating logical knots that resist untangling through conventional reasoning. When you encounter situations involving conditional promises, strategic predictions, or agreements whose terms depend on their own fulfillment, you might remember the ancient crocodile and the clever father. You might reflect on how language can create logical traps as dangerous as any physical snare, how promises can bind us in ways we never intended, and how the attempt to be perfectly rational can sometimes lead to perfect impossibility. The crocodile remains forever poised at the river's edge, the child held gently in its jaws, the promise hanging in the air like morning mist over the water. The father's prediction echoes across the centuries, neither true nor false, but somehow both, creating ripples in the logical structure of reality that spread far beyond the muddy banks where the story began. In this eternal moment of suspended decision lies encoded one of the most fundamental questions about the nature of rational commitment, strategic interaction, and the strange loops that emerge when language turns back upon itself. The crocodile's dilemma becomes our own. A reminder that even the most carefully reasoned promises can lead us into paradoxes where logic itself becomes the cage from which there seems to be no escape. The unexpected, hanging paradox. Picture a courthouse on a grey Monday morning, its stone walls bearing witness to the weight of human judgment and the finality of justice. In the dock stands a condemned prisoner, a man whose crimes have earned him the ultimate penalty. The judge, robed in black and bearing the authority of law and state, prepares to deliver not just a sentence, but a puzzle that will echo through the corridors of logic for generations to come. The prisoner listens as his fate is pronounced with ceremonial gravity. He will be executed by hanging, the judge declares, but not immediately. The execution will take place at noon on one of the 5 weekdays of the coming week, Monday through Friday. This much is certain and non-negotiable, but then the judge adds a condition that seems almost merciful, a final consideration for a condemned man's peace of mind. The day of your execution, the judge intones, will come as a surprise to you. You will not be able to determine in advance which day it will be. When the executioner comes for you that morning, it will be unexpected. The prisoner is led back to his cell, where he sits in the dim light filtering through the barred window, contemplating this strange pronouncement. At first, the judge's words seem to offer little comfort. He will die within the week, and the only mercy is that he will not know which day will be his last. But as the hours pass and his logical mind begins to work upon the problem, something remarkable occurs to him. He realizes that he can prove, through impeccable reasoning, that the execution cannot possibly take place as the judge has described. The logic unfolds in his mind with crystalline clarity, each step following inevitably from the last, building toward a conclusion that fills him with unexpected hope. Consider Friday, he thinks to himself. If he has survived until Thursday evening, if Monday, Tuesday, Wednesday and Thursday have all passed without the executioner's arrival, then Friday must be the day. There would be no other possibility remaining. But if Friday is the only day left, then the execution on Friday would not come as a surprise. He would expect it with absolute certainty. Since the judge has promised that the execution will be unexpected, it cannot take place on Friday. This reasoning seems airtight, but it leads to an even more powerful conclusion. If Friday is eliminated as a possibility, then Thursday becomes the new final day. Suppose he survives Monday, Tuesday, and Wednesday. By Thursday morning, knowing that Friday has been ruled out by logic, Thursday would be the last remaining option. The execution on Thursday would therefore be completely expected, violating the judge's condition that it be a surprise. So Thursday too must be eliminated. The prisoner's excitement grows as he follows this chain of reasoning to its inevitable end. With Thursday eliminated, Wednesday becomes the final possible day, but if he survives Monday and Tuesday, then Wednesday's execution would be fully anticipated. Wednesday, therefore, is also impossible. By the same logic, Tuesday becomes predictable once Monday has passed, so Tuesday is eliminated. And Monday, being the first day, would be expected from the very beginning if all other days have been ruled out. The conclusion is inescapable. The execution cannot take place on any day of the week while satisfying the judge's condition that it be unexpected. The judge has created a logical impossibility, a sentence that contradicts itself. The prisoner allows himself a smile of intellectual triumph. He has used pure reason to prove that his execution, as described, cannot occur. He will live. But when noon arrives on Wednesday, the executioner appears at his cell door. The prisoner stares in shock and disbelief. This cannot be happening. His reasoning was flawless, his logic unassailable. The execution was impossible. He had proved it beyond doubt. Yet here stands the executioner, and the prisoner realizes with dawning horror that he is genuinely completely surprised. This is the heart of the unexpected hanging paradox, also known as the prediction paradox or the surprise test paradox. It presents us with a situation where rigorous logical reasoning leads to a conclusion that is dramatically contradicted by actual events. The prisoner's logic appears perfect, yet it fails catastrophically when put to the test of reality. The paradox reveals something profound about the relationship between reasoning about future events and the actual unfolding of those events. The prisoner's mistake, though subtle, is fundamental. He reasons about what he will expect in various future scenarios, but his very act of reasoning changes what he should rationally expect when those scenarios arrive. Consider what happens on Wednesday morning from a different perspective. The prisoner had concluded that no execution could occur, so he expects no execution on any day. When the executioner arrives on Wednesday, the prisoner is indeed surprised. Not because Wednesday was impossible to predict in advance, but because he had convinced himself that no execution could occur at all. The paradox illuminates the complex relationship between prediction and surprise. To be surprised by an event, one must not expect it, but the act of reasoning about what one will or will not expect can itself change what one should rationally expect. The prisoner creates a kind of logical feedback loop where his reasoning about surprise eliminates the possibility of surprise, but this very elimination makes genuine surprise possible again. This connects to deeper questions about self-reference and reflexivity in logic. The prisoner is not merely predicting an external event, but predicting his own future mental states. What he will expect, what will surprise him, what he can anticipate. This self-referential aspect creates instabilities similar to those found in the liar paradox, where statements about their own truth values generate contradictions. The paradox also reveals important distinctions between different types of knowledge and different temporal perspectives. There is a difference between what can be known in advance and what can be known at the moment of occurrence, between theoretical possibility and practical predictability, between logical necessity and empirical surprise. Consider a variation of the paradox that makes this clearer. Suppose the judge tells the prisoner that the execution will occur at a randomly chosen time during the week, with each day equally likely. In this case, no particular day can be predicted with certainty, and the execution could genuinely be unexpected whenever it occurs. The original paradox emerges because the judge's condition appears to rule out all days, creating the illusion that no execution can occur. The paradox has found applications far beyond philosophy in fields such as economics, game theory, and cognitive science. In economics, it relates to problems of rational expectations and market prediction. If everyone in a market believes that a particular event, like a stock market crash, cannot happen because it would be too predictable, this very belief might create conditions where the event becomes genuinely unpredictable and therefore possible. In game theory, the paradox illuminates problems of strategic reasoning where players must predict not just events, but other players' expectations about events. When players reason about what other players expect them to expect, complex recursive structures can emerge that resist stable solutions. The paradox also connects to questions about the nature of knowledge and belief updating. The prisoner begins with one set of beliefs about when the execution might occur, then uses reasoning to update those beliefs, ultimately arriving at the belief that no execution will occur. But this final belief is contradicted by events, forcing us to ask where the reasoning went wrong. One approach to resolving the paradox focuses on the distinction between subjective and objective surprise. Perhaps the judge means that the execution will be objectively unpredictable. That is, that there is no logical or empirical basis for determining in advance which day it will occur. The prisoner's reasoning might show that subjective surprise is impossible, since he can always construct scenarios where he expects the execution, but objective unpredictability remains possible. From this perspective, the execution on Wednesday is objectively unexpected because there was no way to determine in advance that Wednesday would be chosen. The prisoner's subjective expectations are irrelevant to whether the judge's condition has been satisfied. The execution surprises the prisoner not because it was impossible to predict, but because his flawed reasoning led him to false confidence that no execution would occur. Another resolution focuses on the temporal structure of the problem. The prisoner reasons about his future expectations, but expectations can change as new information becomes available. When Wednesday arrives without an execution on Monday or Tuesday, the prisoner should update his expectations based on this new information, not rely on reasoning conducted earlier in the week. From this dynamic perspective, the paradox arises because the prisoner treats his current reasoning as binding on his future self. But rational agents should be prepared to revise their beliefs as circumstances change. If the prisoner had reasoned correctly, He would have realized that surviving to Wednesday would provide new information that should lead him to expect a possible execution that day. The paradox also raises questions about the relationship between logical possibility and practical feasibility. The prisoner's reasoning shows that no day can be logically guaranteed to provide a surprise execution, given the judge's conditions. But this does not necessarily mean that a surprise execution is impossible, only that it cannot be guaranteed through purely logical means. Perhaps the judge is making a weaker claim than the prisoner assumes. Instead of promising that the execution will definitely be a surprise, the judge might be saying only that he will attempt to make it surprising, or that it will be surprising under normal circumstances. This weaker interpretation avoids the logical contradictions that plague stronger versions of the promise. Educational versions of the paradox involving surprise tests rather than executions have been widely studied in cognitive psychology and philosophy of education. A teacher announces that there will be a surprise test during the coming week, leading students to reason that no such test is possible. When the test occurs, students are indeed surprised, but this raises questions about the nature of educational promises and the psychology of expectation. These educational versions reveal practical aspects of the paradox that the execution version obscures. In real classrooms, students who reason that a surprise test is impossible might simply not study, making any test genuinely surprising. The paradox becomes self-fulfilling in ways that illuminate the complex relationship between reasoning, preparation, and surprise in practical contexts. The paradox also connects to questions about the nature of promises and commitments. When the judge promises that the execution will be unexpected, is this a commitment to a particular state of affairs, or merely a prediction about what will likely happen? If it is a genuine promise, then the judge must have some way of ensuring that the condition is met, but the paradox suggests that no such guarantee is possible. This raises broader questions about the limits of what can be promised or guaranteed when dealing with future events that depend partly on the promiser's own actions and partly on the recipient's reasoning and expectations. Some types of promises might be inherently self-defeating, creating logical structures that make their own fulfillment impossible. The paradox has also been analyzed through the lens of modal logic, which deals with necessity, possibility, and counterfactual reasoning. The prisoner's argument appears to show that it is necessarily true that no surprise execution can occur. But the actual occurrence of a surprise execution seems to demonstrate that the prisoner's reasoning about necessity was flawed. This modal analysis suggests that the paradox reveals confusions about the relationship between what is necessarily true and what can be known to be true in advance. Something might be necessarily possible without being predictably actual, or necessarily unpredictable without being necessarily non-existent. Information theory offers another perspective on the paradox. Surprise, from an information theoretic standpoint, relates to the probability assigned to an event before it occurs. An event is surprising if it had low subjective probability. The prisoner's reasoning assigns zero probability to any execution occurring, making any actual execution maximally surprising from his subjective perspective. But information theory also suggests that surprise depends on the information available at the time of prediction. If the prisoner has incomplete information about the judge's decision-making process, then events that seem impossible given his information might still be possible given the complete information available to the judge. The paradox ultimately reveals the subtle complexities involved in reasoning about future events, particularly when those events depend partly on the reasoner's own expectations and beliefs. It shows how logical reasoning, even when applied correctly to correct premises, can lead to conclusions that are dramatically falsified by experience. Perhaps the deepest insight offered by the unexpected hanging paradox is its demonstration that prediction and surprise exist in a delicate relationship that can be destabilized by too much analysis. The prisoner's attempt to eliminate uncertainty through pure reasoning creates a different kind of uncertainty. The uncertainty that comes from reasoning oneself into false confidence. When you face situations where someone promises you a surprise or when you try to predict events that depend partly on the predictions themselves, you might remember the condemned prisoner and his fatal confidence in logic. You might reflect on the limits of reasoning about your own future mental states, the dangers of assuming that logical possibility and practical feasibility are identical, and the mysterious ways in which surprise can emerge from the very attempts to eliminate it. The executioner stands forever at the cell door in the landscape of human thought, arriving at a moment that logic proved impossible but experience confirms as real. The prisoner's shock echoes across the centuries, not just the surprise of an unexpected execution, but the deeper surprise of discovering that flawless reasoning can lead to perfectly false conclusions. In this eternal moment of contradiction between logic and reality lies encoded one of the most important lessons about the relationship between reasoning and experience, between what we can prove and what we can know, between the maps our minds create and the territory through which we must actually walk. The paradox reminds us that logic is a powerful tool for understanding the world, but that the world itself always retains the capacity to surprise us in ways that our finest reasoning cannot anticipate or prevent. The Pinocchio paradox. In a small Italian village nestled among rolling hills, covered with olive groves and vineyards, there once lived a lonely woodcarver named Geppetto. His workshop, filled with the sweet scent of pine shavings and the gentle sounds of chisel against wood, became the birthplace of something extraordinary. A marionette carved with such love and skill that it seemed almost alive even before magic touched it. This wooden boy, whom Geppetto named Pinocchio, would become more than just a beloved children's tale. He would embody one of the most perplexing logical puzzles ever conceived. The Blue Fairy, moved by Geppetto's devotion, granted the puppet a form of life, but with a peculiar condition that would govern his journey toward becoming a real boy. Whenever Pinocchio spoke a lie, his wooden nose would grow longer, serving as an unmistakable indicator of deception. This magical mechanism seemed straightforward enough, a perfect truth detector that would help guide the puppet toward honesty and moral growth. For years, this simple rule worked exactly as intended. When Pinocchio claimed he had gone to school but had actually skipped class to watch a puppet show, his nose extended betrayingly. When he insisted he hadn't eaten Geppetto's breakfast, when crumbs still clung to his wooden chin, the appendage stretched outward like an accusatory finger. The enchantment served its purpose, making deception impossible to hide and encouraging the puppet toward truthfulness. But one day, in a moment of either profound insight or innocent confusion, Pinocchio uttered a statement that would shatter the logical foundation of his magical curse. Standing before a mirror in Geppetto's workshop, examining his reflection with the curious intensity that only children possess, the wooden boy spoke 5 simple words that created an impossible situation. "My nose will grow now." In that instant, the Blue Fairy's enchantment encountered a logical trap that had no resolution. Consider what must happen if Pinocchio's statement is true. If his nose truly will grow as he claims, then he has spoken the truth, and the magical rule dictates that his nose should not grow when he tells the truth. But if his nose does not grow, then his prediction that it will grow turns out to be false, meaning he has lied. And if he has lied, then according to the enchantment, his nose should indeed grow, making his original statement true after all. Conversely, consider what happens if Pinocchio's statement is false. If his nose will not grow as he claims it will, then he has told a lie, and the magical rule requires that his nose grow as punishment for deception. But if his nose does grow, then his prediction was actually correct, meaning he told the truth. And if he told the truth, then his nose should not grow, contradicting what we just established must happen. This is the essence of the Pinocchio paradox, a modern variation of the ancient liar paradox that uses the beloved character's magical condition to illustrate how self-reference can create logical impossibilities. The Wooden Boy's simple statement creates a circular trap where every possible resolution leads back to contradiction. The paradox reveals something profound about the relationship between truth, falsehood, and self-reference in logical systems. Pinocchio's nose was designed to be a perfect lie detector, an infallible mechanism that would always correctly identify deception. But the paradox shows that no such perfect detector can exist when it must evaluate self-referential statements about its own operation. This connects to fundamental problems in logic and computer science known as the halting problem and Gödel's incompleteness theorems. These mathematical results demonstrate that there are inherent limits to what formal systems can determine about their own behavior. The Pinocchio paradox provides an intuitive illustration of these deep logical limitations through the familiar story of a wooden puppet's journey toward becoming real. The paradox also illuminates the complex relationship between intentions and outcomes. When Pinocchio speaks, is he trying to tell the truth or deliberately attempting to create a paradox? His motivation affects how we interpret the statement. If he genuinely believes his nose will grow and is simply sharing this expectation, then he might be attempting honesty despite the logical problems this creates. But if he is cleverly trying to trap the magical system in contradiction, then his intent might itself be deceptive, adding another layer to the paradox. This question of intention reveals the psychological dimensions hidden within logical puzzles. Real people have motives, beliefs, emotions, and mental states that affect how they use language. Unlike abstract logical systems, human communication occurs in contexts rich with meaning, history, and purpose. The Pinocchio paradox emerges at the intersection between the formal structure of logic and the messy complexity of intentional communication. The paradox also raises questions about the nature of magical rules and their relationship to logical consistency. In fairy tales, we typically accept magical elements as operating according to their own internal logic, even when that logic differs from natural law. But the Pinocchio paradox suggests that even magical systems must obey certain logical constraints if they are to remain coherent. This has implications for fantasy literature, game design, and any creative endeavor that establishes alternative rules for fictional worlds. The paradox serves as a warning that magical or supernatural elements, no matter how fantastical, can create logical contradictions if their rules are not carefully constructed. A perfectly reliable lie detector, even a magical one, may be logically impossible when self-reference is permitted. The paradox becomes even more interesting when we consider the broader context of Pinocchio's journey. The puppet's quest to become a real boy involves learning about truth, responsibility, and moral growth. His growing nose serves not just as punishment, but as education, helping him understand the consequences of deception and the value of honesty. But what lesson could Pinocchio learn from a statement that is simultaneously true and false? How could the Blue Fairy's enchantment guide him toward moral growth when it encounters a situation that has no moral resolution? The paradox suggests that some aspects of truth and falsehood may be too complex for simple moral categories. This educational dimension of the paradox connects to broader questions about moral instruction and the limits of rule-based approaches to ethics. If even a perfect lie detector can be confused by sufficiently complex statements, then perhaps moral guidance requires more than mechanical application of simple rules. Real ethical thinking might demand the kind of flexible reasoning and contextual judgment that rigid systems cannot provide. The paradox also reveals interesting aspects of the relationship between prediction and self-fulfillment. When Pinocchio says his nose will grow, he is making a prediction about his own future state. But his prediction itself becomes part of the causal chain that determines whether the prediction comes true. This creates a feedback loop where the prediction affects its own truth value. Similar self-referential predictions appear throughout human experience. When economists predict a recession, their prediction can influence behavior in ways that either cause or prevent the recession they forecast. When weather forecasters predict rain, people might carry umbrellas or cancel outdoor events, changing the social reality even if the meteorological prediction proves incorrect. The Pinocchio paradox illustrates how predictions about systems that can respond to predictions create special logical challenges. The puppet's nose is not just a passive indicator, but part of an active system that changes in response to what Pinocchio says. This responsiveness creates the possibility for self-referential statements that generate paradox. Modern artificial intelligence faces similar challenges when designing systems that can reason about their own behavior. If we create a machine that can make statements about its own future actions, we risk creating digital versions of the Pinocchio paradox. The machine might declare that it will perform a certain action if, and only if, it determines that this declaration is false, creating logical loops that resist resolution. These AI applications of the paradox are not merely theoretical. As computer systems become more sophisticated and more capable of self-reflection, they increasingly encounter situations analogous to Pinocchio's dilemma. A system designed to detect its own errors might stumble over self-referential statements about its error detection capabilities. The paradox also connects to questions about the nature of fictional truth and the logic of storytelling. Within the world of the Pinocchio story, certain facts are established. The puppet exists, the blue fairy's magic is real, the nose-growing enchantment operates reliably. But the paradox suggests that even well-established fictional worlds can contain internal contradictions that resist resolution within the story's own logic. This raises fascinating questions for literary criticism and narrative theory. Can a story be internally consistent while containing logical paradoxes? Should authors worry about the logical coherence of magical elements in their fictional worlds? The Pinocchio paradox suggests that perfect logical consistency might be impossible to achieve, even in carefully constructed fictional universes. The visual and physical aspects of the paradox add another dimension to its philosophical significance. Unlike purely abstract logical puzzles, the Pinocchio paradox involves a concrete, physical change, the growth of a wooden nose. We can visualize the dilemma. Imagine the puppet standing before a mirror as he speaks the fateful words. Picture the moment when logic and reality collide. This embodied quality makes the paradox more accessible and memorable than many philosophical puzzles. The image of Pinocchio's nose, frozen between growing and not growing, captures the essence of logical contradiction in a way that purely verbal formulations cannot match. The physical impossibility mirrors and reinforces the logical impossibility. The paradox also invites reflection on the relationship between appearance and reality, a theme central to the original Pinocchio story. The puppet's journey involves learning to distinguish between surface appearances and deeper truths, between the immediate gratification of deception and the lasting satisfaction of honesty. But the paradox reveals a situation where the distinction between appearance and reality breaks down completely. When Pinocchio says his nose will grow, we cannot determine whether this appearance corresponds to reality because reality itself becomes contradictory. The paradox suggests that some truths may be too complex for simple correspondence theories of truth, which define truth as agreement between statements and facts about the world. The temporal dimensions of the paradox deserve special attention. Pinocchio's statement is about the future. He claims his nose will grow, not that it is currently growing. This temporal aspect creates additional complexity because it involves predictions about future states that depend on present statements. Time flows forward, but logical relationships exist outside time. When Pinocchio speaks, his statement creates a logical structure that seems to exist independently of the temporal sequence of events. The paradox emerges from the collision between temporal causation, statements preceding their effects, and logical relationships, statements being true or false regardless of when they are made. The social context of the paradox also matters. Pinocchio typically speaks to other characters, Geppetto, the blue fairy, Jiminy Cricket, other children. But the paradoxical statement seems directed at no one in particular, or perhaps at the magical system itself. This self-directed quality removes the usual social functions of communication and focuses attention purely on the logical structure of the statement. In normal conversation, we use context, tone, gesture, and shared understanding to resolve ambiguities and clarify meaning. But the Pinocchio paradox strips away these social supports, leaving us with a statement that must be evaluated purely on its logical merits. This isolation reveals how much we typically rely on context to make sense of language. The paradox ultimately suggests that truth and falsehood may be more complex categories than our everyday experience suggests. We typically think of statements as having definite truth values that can be determined through observation, reasoning, or reference to facts. But the Pinocchio paradox reveals statements that seem to resist this binary classification. Perhaps some statements are neither true nor false, but belong to a third category: indeterminate, paradoxical, or self-referentially problematic. This possibility challenges classical logic, but might be necessary to handle the full complexity of language and meaning in both fictional and real-world contexts. When you encounter promises, predictions, or claims that refer to themselves or to their own truth conditions, you might remember the wooden puppet standing before his mirror. You might reflect on the delicate relationship between self-reference and logical consistency, between the rules we create to govern behavior and the exceptions that test those rules' limits. Pinocchio remains forever frozen in that moment of impossible utterance, his nose poised between growth and stillness, his statement suspended between truth and falsehood. In his wooden face lies encoded one of the deepest questions about the nature of truth, the limits of logical systems, and the mysterious ways in which language can trap itself in webs of its own creation. The Blue Fairy's magic encounters the boundaries of logic itself, revealing that even the most powerful enchantments cannot overcome the fundamental paradoxes that arise when meaning turns back upon itself. The puppet's journey toward becoming real leads him to a place where reality itself becomes paradoxical, where the simple desire to speak truthfully generates impossible contradictions that no magic can resolve.